दिसत नाही. हे बघा बरं. हॅलो, बघा की आहे, मी जॉईन झालो. ठीक आहे, समोर दिसतंय की. आवाज येतोय का बघा जरा. हॅलो, व्हिडिओ चालू करू काय? हॅलो,
मीच आहे.
हॅलो.
ऑडिबल नाहीये, अजून चालू नाही का?
Hello. Now we will start within 5 minutes. Hello. Good morning, one and all. On the behalf of RayatShikshanSanstha's RajarshiChhatrapatiShahuCoge, Kolhapur, Department of Physics, I welcome you all for this workshop on New Changed BSc Part 3 CBCS Curriculum of Physics Paper 9 and Paper 12. It gives me immense pleasure to extend you a very warm welcome. Our college has clubbed all of us for this workshop. Education through self-help is our motto. Karmavir Bhaurao Patil was a social activist and educator in Maharashtra. He played an important role in educating backward caste and low-income people. Let's start the inauguration of this workshop with our RayatShikshanSanstha.
केले बघा. ओके ओके.
वृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. कर्मवीरांचे ज्ञानपीठ हे शक्तिपीठ ही ठरते आहे. शाहू फुल्यांचे समानतेचे तत्वमानसी मूर्ते आहे. धर्म जातीच्या पाद गांधींचे मूल्य मानवी जपतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. गरिबासाठी लेणी मोडून लक्ष्मी वहिनी झाली आई. कमवा आणि शिका मंत्र हा तरुणाईला प्रेरक होई. स्वावलंबी वृत्ती ठेवून ज्ञान साधना करतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. दलितांसाठी अण्णा तुमची झिजली चंदन काया. अनाथ जीवा सदा लाभली मातृहृदयी तुमची माया. शून्यामधल्या नवसृष्टीचा निर्मिक तोही ठरतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा. जीवनातला तिमिर जावा प्रबोधनाची पहाट व्हावी. इथे लाभले पंखले उनी उंच भरावी नभात घ्यावी. प्रतिभाशाली बहुजनांचा वेलू गगनी चढतो आहे. रयते मधुनी नव्या युगाचा पाऊस आता झडतो आहे, वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे, रयते मधुनी नव्या युगाचा.
Everything is in it. Your thoughts begins it, your emotion amplifies it, and your action increases the momentum. Now I request our Honorable Vice Principal Sir, Dr. R.S. Dubal Sir, to deliver his welcome address. Over to you, sir.
Hello. Hello.
Yes, sir.
Am I audible?
Yes, sir.
Yes, sir. Okay. Good morning, one and all. I heartily welcome Professor K.Y. Rajpure, Chief Guest of today's function, all the resource persons of this online webinar, Honorable Principal Dr. S.K. my colleague Dr. Killedar, Head Department of Physics, Organizing Committee, and dear participants. At the outset of one-day workshop on changed BSc3 curriculum of the paper 9 and 12, let me introduce you with Mother Institute RayatShikshanSanstha Satara and my college. First of all, about RayatShikshanSanstha Satara. RayatShikshanSanstha, it is the Mother Institute of RajarshiChhatrapatiShahuCoge Kolhapur, was established by late Padma Bhushan Dr. Karmveer Bhaurav Patil in the year 1919. It is one of the leading institutions in the Asia. The Sanstha has celebrated its centenary year in 2019. The value of its contribution to education in general is enormously great, as it has from the very beginning and tried all its best to lay emphasis on the education of downtrodden, the poor and ignorant that really form the major bulk of the society. The founder of the institution, late Dr. Karmveer Bhaurav Patil, was a man of masses who devoted all his mind and heart to the causes of their education. The institute's motto, education through self-help, speaks for its emphasis upon the dignity of labor and its social orientation. During the last 90 years, RayatShikshanSanstha has proliferated to such an extent that today it runs 41 senior colleges, 2 B.Ed colleges, 1 engineering college, 1 law college. The Sanstha also runs 432 secondary schools, 25 primary schools, 36 pre-primary schools, 74 cosmopolitan hostels, 4 ashram shalas, residential schools for Adivasi students, 6 industrial training institutes, 8 B.Ed colleges, 158 junior colleges, 7 regional offices, and 59 other branches. A total of 18,019 devoted staff serve in 14 districts of Maharashtra and 1 district in Karnataka to impart knowledge to more than 4 lakh students. The budget of the Sanstha is about 3.5 billion rupees. Sanstha's 14 colleges are accredited with A grade by NAAC. 6 colleges of the Sanstha has autonomous status. The outstanding work for the poor and deprived performed by the Sanstha in the spirit of the missionaries has been honored with Dr. Baba Saheb Ambedkar Award by Government of India, Dalit Mitra Puraskar by Government of Maharashtra, RayatShikshanSanstha by Government of Maharashtra, RajarshiChhatrapatiShahuCoge by the Kolhapur, then Sant Gadge Bara Seva Pratishthan Puraskar by Mumbai, and Dr. Panjabrao Deshmukh Smriti Puraskar from Akola. Now about the college. The RajarshiChhatrapatiShahuCoge is established in year 1962. The college was named as RajarshiChhatrapatiShahuCoge, Kolhapur, in the memory of Rajarshi Shahu Maharaj of Kolhapur, a great social reformer of Maharashtra. The college has celebrated its golden jubilee year in 2011-12. Recently, our college is re-accredited with A grade with CGPA 3.07 in third cycle of NAAC. College is awarded with Karmveer Parithoshik in year 2015 by RayatShikshanSanstha Satara. Our college has established its reputed institute providing quality education in the field of arts, commerce, science, and computer science to the students from slum areas and deprived sections of the society. The college is known for its wrestling and kabaddi tradition and produced huge number of sportsmen at national and international level. Mr. Sambhaji Patil and Dr. Ramesh Bendigiri, Director of Physical Education, is honored with Shiv Chhatrapati Puraskar by Government of Maharashtra, Kolhapur Bhushan Puraskar by Krida Sangatak Puraskar, Dadoji Kondev Award by Government of Maharashtra, and Motilal Joshi Foundation Puraskar. Recently, Dr. Ramesh Bendigiri is honored with international status as the chief coach for Thailand girls kabaddi team and working as a coach for pro kabaddi competition. College runs PG programs, the self-financial courses, career-oriented certificate courses, skill-based courses, competitive exam center, Rayat Military Academy, vocational courses to facilitate the need of the students. College has active placement and counseling cell for overall development of the student. Majority of the faculty is engaged in research and completed number of minor and major research projects. The college wear well-equipped laboratories and swimming tank at Olympic standard. With this brief introduction of RayatShikshanSanstha and my college, once again, I welcome all of you for online seminar organized by Department of Physics and IPC. I wish you all the best for the workshop. Thank you. Jai Karmi.
Thank you, sir. Now I would like to call Dr. V.V. Keledar, sir, to introduce about this workshop and about our chief guest. Dr. V.V. Keledar, sir, member of Board of Studies and Head Department of Physics. Over to you, sir.
Thank you, madam. Good morning, one and all. I'm pleased to welcome Professor K.Y. Raj, Principal S.T. Shahu, Vice Principal Dr. R.H. Dubbal, all HODs and faculty, organizing committee members, and all my participant friends from various colleges who joined the workshop in online mode. I express great sense of gratitude to Shivaji University Kolhapur for providing financial assistance to organize this workshop. First,
सर अनम्यूट करा तुम्हाला सर किल्लेदार सर
okay. Department of Physics is established in June 1992. The department is inaugurated with the auspicious hands of Professor Dr. Michael Newman Speller, CNRI Lab, France. Department is rich in terms of resources and infrastructure and has enough latest audio-visual equipment which supports the ICT teaching learning. The department organizes extra and co-curricular activities such as conferences, seminars, group discussion, projects, parent-teacher meets, guest lectures, debates, study tours, celebrations of important days, etc. for the overall development of the student. Faculty from department is engaged in research work and completed minor research projects and published a number of research papers in national and international journals with high repute. One of the faculty, Dr. V.V. Keledar, has published a reference and textbooks. Dr. V.V. Keledar, HOD Physics, is honored with Best Teacher Award by Vatsalya Foundation, Kolhapur. Dr. Keledar is working as chairman and member on various committees of RayatShikshanSanstha and Shivaji University, Kolhapur. Now about the workshop. You all know that Shivaji University, Kolhapur has started implementing the CBCS pattern for UG classes since academic year 2018-19. The university has already changed the curriculum of BSc 1-2 class, and now from this year, the change in curriculum is implemented for BSc 3 class. I congratulate BOE chairman and all BOS members for putting their efforts in designing the curriculum. Especially, I thanks to Honorable Pro Vice Chancellor Professor Dr. P.S. Patil, sir, for his encouragement and valuable guidance to us. The object The objective of this workshop is to aware the teachers about the change the curriculum and guide them about the details and important aspects of curriculum like COs while teaching the curriculum. Once again, I welcome the dignitaries and participants to this workshop and request you to attend the workshop seriously and raise your queries so that these queries can be forwarded to BOS and right action will be taken. Thank you. Jai Hind. Now let me introduce the today's chief guest, Professor Dr. K.Y. Rajpure. Dr. K.Y. Rajpure is currently working as professor and head in the Department of Physics of Shivaji University, Kolhapur. He has completed BSc degree at RayatShikshanSanstha Science College, Lonan in 1992 with University first rank. He completed his MSc in 1994 and secured the first rank in Shivaji University. After MSc, he had chosen research as a means for career development. In 2000, he was awarded a PhD degree in physics for research in semiconductor septum storage cell under the guidance of Professor C.H. Bhosle. He has qualified SET exam in physical science in year 2002. Though his research was started with storage cells, by the time he spread his wings in various research areas. His later research areas include solar cells, transparent conducting oxides, photoelectrochemistry, and gas sensors. He has been expert in photoelectrolysis. The honor of starting photo detector research in Shivaji University is to his credit. Currently, he is working on an electronic memory devices, namely Memristor also. Now, he has published more than 200 research articles in international journals and received over 7,800 citations with H index 53. He successfully guided 14 PhDs and 2 MPhils. Currently, 5 PhD scholars are working under his guidance. He published 5 books and filed 2 patents. He completed research projects worth 86 lakh rupees. He has worked as head of UC, CFC and coordinator of DST, SAI, Kolhapur Center for 4.5 years. He was instrumental in procuring modern sophisticated analytical facilities at the center. He is a live member of various science associations, namely MRSI, SSI, IPA, IAPT, ISCA, MVP, etc. He is a fellow of the Maharashtra Academy of Sciences since 2015. He is the chairman of the Board of Studies in Physics and a member of the Academic Council of Shivaji University. He is a member of BOS in various institutes, namely Karnataka University, Dharwad, JSPM's RajarshiChhatrapatiShahuCoge College of Engineering, Chhatrapati, Pune, EC College, Baramati, Kolhapur College of Engineering, Sangli, Vivekanand College, Kolhapur, ABP College, Pandharpur, DKT, Sarkhandi, etc. Recently, a feather of international recognition has been added to his crown. Experts from Stanford University, USA, published a list of the top 2% of scientists from all over the globe, and he has been placed in this top 2% of world scientists in the time. I have gone through the deep biodata of Professor Dr. K.Y. Rajpure. Once again, I welcome Professor Dr. K.Y. Rajpure sir to our workshop. With this brief introduction, I hand over to the Malvekar Madam. Thank you.
Thank you, sir. Now I would kindly request the chief guest of this session, Professor K.Y. Rajpure sir, to guide us. Professor K.Y. Rajpure sir, Chairman of Board of Studies, Head Department of Physics, Shivaji University, Kolhapur.
Hello.
Yes, sir, you are audible.
Yeah. Thank you very much, Dr. V.V. Kiledar sir, for the introduction and for the invitation to be a chief guest of this very workshop, one-day online workshop on new changed BSc 3 syllabus as per the CBCS pattern of physics paper number 9 and 12. Before a couple of days, we had the first workshop in this series on the role of experiment and practical physics being organized by another college of RayatShikshanSanstha, Balan College, Bhutan. So I'm really once again honored to be here amongst you. As mentioned by Dr. Kiledar, I am a product of Rayat. I graduated from Science College Lonan in 1992. I really love to be a part of any function, any gathering of RayatShikshanSanstha. I am really obliged to my teacher and principal, Dr. S.T. Salunke sir, who has been my teacher, my inspiration, and a guide. I am also thankful to Dr. R.S. Dubal sir, who is the vice president and president of today's function, for giving me this opportunity. I again take the names of my colleagues in Board of Studies. They are there. Resource persons of today's workshop, namely Dr. Kiledar, Dr. Shinde, my respected teacher, Dr. J.B. Thorat sir, then U.K. Moite sir, and coordinator, Dr. Archana Patil, madam, for inviting me to be part of this August gathering. In the last workshop, the points which I have covered, I will skip. I will skip and I will just revisit the points which I have covered in the previous workshop. And the points were need of changing curriculum. We know in view of changed education policy, new education policy, we call it as a NEP 2020. It is necessary to change the syllabus, taking into account the happenings in the subject, updating ourselves so far as recent knowledge in physics is concerned. Also, we have implemented the CBCS pattern. I have told the advantages of the CBCS pattern in my previous talk. Also, the role of experiment or the practicals in physics learning, that this point also I have highlighted. Friends and teachers, I am very happy to share the fact that since 11th standard, I was having A group and I opted the subject like physics, chemistry, electronics, and mathematics. Coincidentally, today's workshop is on the two papers, namely mathematical physics and electronics, which are my favorite subjects. And I'm also happy to share the fact that if the student, if he opts mathematics and electronics since beginning, maybe from 11th standard, it becomes very easy for him to take the education up to postgraduate and again complete the PhD. It becomes very easy for him. I will give you the examples why it is so. Before going to my deliberations, only few I will take, only 5 minutes I will take. But before that, I would like to advise. Of course, I am not so great a personality to advise the teachers who are my teachers, physics teachers. But even then, what I feel, being the chairman of Board of Studies in Physics, I should share these facts with the teachers. Teachers should always train the students not as examiners, but they should be real, in a real sense, students. मराठीमध्ये सांगायचं असेल तर त्यांना परीक्षार्थी करू नका, त्यांना विद्यार्थी करा. आणि विद्यार्थी जेव्हा शिक्षक होतो त्यावेळेला खऱ्या अर्थानं विद्यार्थी होतो. सो ऑल द टीचर्स आर रिक्वेस्टेड टू ट्रेन आवर स्टुडंट्स not for the examiners, not being examiners, but in a real sense students. We should not train copycat, but we should train think tanks. This should be aim of our physics teachers. Also, maybe in the next revision of the syllabus, this point all board of studies member and all senior faculty members, they will take up these points, that our syllabi or curriculum should include the topics like the topic Bose-Einstein condensation, not only in the theoretical sense, but the practicals based upon this, simple practicals. So we should take up the experiments, we should put these topics in our curriculum. Also, it is duty of every physics teacher to explain to his BSc 3 physics students the subject for which that current year Nobel Prize was awarded. So that will update the knowledge of the students, and that will give it will be possible for us to attract many students to the physics subject. So far as the topics of today's workshop are concerned, or the papers of today's workshop are concerned, they are two: mathematical methods in physics and the electronics. So I will just brief you within 1 or 2 minutes why we should concentrate on these two subjects, why we should rigorously take these two subjects. I personally feel this physics is not the subject which should be studied in compartments. We should not label this part is a mathematical physics, this is quantum mechanics, this is mathematical physics, this is electrodynamics. We all should learn physics as what we can say as a monolithic subject. Whenever required, we jump to quantum theory. Whenever required, we go to physical principle. Whenever required, we go to mathematical principle. And in this way, our journey to learn physics should be. So subject should not be learned in the compartment. Of course, say for the sake of simplicity and for the sake of convenience of our teachers and our syllabi, we categorize it as a paper number 1, 2, 3, 4, etc., etc. But in the student's perspective and in the teacher's perspective, we should not make this physics, divide the physics into compartment. Maybe my teachers will agree on this point. There was a debate on the Einstein belongs to physics or mathematics. So that was actually nonsense debate, I feel, because there is no boundary between mathematics and physics. I will say for learning mathematics, you need physical principle, and for understanding physics, we need mathematical methods. So both of these, they go hand in hand. Therefore, Einstein belongs neither to physics nor to mathematics. He belongs to the science. That's what I feel. So mathematics is a tool to answer the questions, physical problems which we want to solve. For example, Newton invented calculus to help to describe motion. So calculus is a mathematical method. Therefore, mathematics is a tool, and we need to learn this mathematics as a part of the physics. Also, this mathematical physics bridges the gap between what you can say the physics and the description, or the what you can say the description of a nature. Physics and the description of the nature. So mathematical physics bridges the gap between these two. The physicists use, for example, algebra, for example, calculus, for example, means differential calculus, integration calculus, integral calculus, differential equation, linear algebra, group theory to unveil the physical processes. What I personally feel, while teaching students how to solve differential equations to get the solution, we should again or equally train them, teach them how to solve differential equation numerically. So this also one should take into account. As far as electronics is concerned, it is a branch of physics where we deal with electron and the motion of electron and the devices based on the what you can say, the motion of the electrons. And we learn in the electronics how one can use the electronics in the physics domain. Today's generation is a generation of electronic devices. We take any gadget, take example of any gadget, the electronics is involved in that. So to understand the working of these gadgets, one needs to clarify for example, Boolean algebra. I still remember the classes by respected Dr. J.B. Thorat sir, who taught me the binary system, number system, and the Boolean algebra long back in 1989. So these fundamentals of the electronics, they should be taught to the physics students. Also, the electronic devices like computer, mobile apps, ITM, pen drive, television, camera, all these are based on these electronic principle. So, if you ask any student how mobile can be operated, they can immediately tell. How email can be sent, they can immediately send the email. But they don't know, but they are not able to tell the way in which this email is transmitted from one end to other. So I feel we should train our students. We should teach the electronic principle to the students. Hope today's speakers, and they will focus their attention not only on the curriculum and the points in the syllabus, but we should create a curiosity among the students' mind. We should put in front of them few questions so that they will learn by
electronics मध्ये.
So our aim should be create questions among the students' mind. Take any example, maybe mathematical physics or maybe electronics. So these were the things which I thought I should share with my teachers and the teachers who are teaching. These teachers need not do any new thing. They need to adopt their routine method of teaching their curriculum, the subject from mathematical physics and electronics. But the very facts which I shared, those should be considered while teaching, while training the students. Once again, I take this opportunity to thank organizers, particularly Dr. Killedar, for inviting me to be the chief guest of today's function. And I take your leave because I have another meeting. Thank you very much. And I wish all the best, all the very success for this workshop. Thank you one and all. Have a good day.
Thank you, sir. Really, we should train think tanks, monolithic subject and not in the compartments. Thank you, sir, for your valuable guidance and giving us your precious time. Thank you once again. Now, I would like to call Dr. Tejasvi Kurne ma'am to propose vote of thanks for this.
Thank you, ma'am. I am Dr. Tejasvi Kurne, here to express vote of thanks. I am thankful to today's chief guest, Professor Dr. K.Y. Rajpure sir, Head, Department of Physics, Shivaji University, POS Chairman in Physics University, Kolhapur, for accepting our invitation and sparing his valuable time with us and guiding the participant. I am thankful to Dr. S.T. Salunke sir, principal of our college, for inspiring and guiding us during all part of the workshop. I am thankful to Vice Principal Dr. R.S. Dubal sir for presiding the inaugural function and guiding us. I am thankful to Resource Chairperson, Convener of the workshop, Dr. V.V. Killedar, Coordinator of the workshop, Dr. Archana Patila, Organizing Committee member for their neat organization of the workshop. I am also thankful to all participants for their overwhelming responses. Thank you to all.
Thank you, ma'am. Now, without consuming our precious time, let's begin with our first invited talk. I would kindly request Dr. R.K. Nimat sir to chair this session and also introduce about resource person of the first invited talk. Dr. R.K. Nimat sir, Associate Professor, B.D. Desai College, Patan. Over to you, sir.
Hello, am I audible?
Yes, sir.
Yeah, please. First of all, very good morning to all the participants and our beloved head of the department physics, Shivaji University, Kolhapur, Dr. Professor Rajpure sir, Principal Saunke sir, Vice Principal R.S. Dubal sir, head of the department of physics of Shahu College, Dr. V. Killedar sir, and my fellow colleagues and dear participants. We are beginning the first session of this workshop. As we know that today we are going to discuss the two papers, paper number 9 and paper number 12. So I will be the chairperson of the paper number 12, and the first speaker of this session is Dr. V. Killedar sir. He will be discussing the first unit of this paper number 12, and the unit is digital electronics, transistors, amplifier, and sinusoidal oscillators. It's my privilege to introduce such a great personality in the physics community, Dr. V. Killedar sir. As we know that he is well known to all the physics community, even though as a part of this syllabus, I would like to give some brief introduction about Dr. V. Killedar sir. Dr. V. Killedar sir is presently working as an associate professor and head of the department of physics at RajarshiChhatrapatiShahuCoge, Kolhapur. He has a total 32 years of teaching experience. He has shouldered a lot of responsibilities in the RayatShikshanSanstha. He has worked as the in-charge principal at Shahu College, Kolhapur. He has worked as an in-charge of science faculty at Shahu College, Kolhapur. Presently, he is a board of studies member in physics for Shivaji University, Kolhapur. He has worked as a chairman for LIC committees of the Shivaji University, Kolhapur. He has worked as a NAAC coordinator and he has been awarded with the best teacher award. Just he has mentioned a while ago, that award was given by the Vasalya Foundation, Kolhapur. In research areas, he has done a good contribution. He is the recognized PhD guide and MPhil guide in physics for Shivaji University, Kolhapur. One student has been awarded PhD degree under his guidance, and he has completed two research projects funded by the University Grants Commission. He has presented national and international journals with high repute. And he has attended so many academic conferences which were held in India and abroad. He has published many books, and some of books that we are using as a textbook for our syllabus teaching, and he has written some reference book also. He has delivered many guest lectures, and he has worked as a resource person in national and state level conferences, and he has been associated with the various extracurricular and co-curricular activities organized by department and RayatShikshanSanstha. So today we have with us a very great personality in the physics. I request Dr. Killedar sir to discuss the unit number 1 of the paper number 12, digital electronics, transistors, and etc. Over to Dr. Killedar sir.
Thank you, Dr. Nimat sir, for a nice information. Now I am going to discuss paper number 12, unit number 1. The paper 12 is DSC E4, Digital and Analog Circuits and Instrumentation. Now let us see the details regarding the unit 1 from this syllabus. Now before going to 1 minute. Now, before going to see the paper number 12, let us see the overall structure of our BSc 3 course. During semester 5, we have to complete or we have to study 4 theory papers of 50 marks and each has 2 credits. During the semester 6, we have to again cover 4 more papers. Again, for each paper is for 50 marks and allotted credits are 2. Along with this, we have to also complete practical course, which is for 200 marks, and the total number of credits allotted for this practical course is 8. So total examination for BSc Part 3 is of 600 marks and number of credits given to the student is 16. So I request all the teachers to go through the credits. You should be able to explain the student how the CGPA is calculated and how the grade is given to the student. Because the students are not aware of all these facts. They simply knows that percentage of marks. But in the CBCS system, now the grade is allocated by the university to the student. So make aware of the students about these credits, the CGPA and their grades. That is also very important. Now let us concentrate on paper number 12, that is DSE E4, Digital and Analog Circuits and Instrumentation. So this is a discipline specific elective course. Discipline specific elective course. Again, each paper has 2 units. Unit 1 is for 8 hours and which includes 2 topics, digital electronics, and the second one, that is transistor amplifier and sinusoidal oscillators. The unit 2 is cathode ray oscilloscope, operational amplifier and timer IC55. So I am going to discuss with you the unit 1. So if you consider the curriculum of this unit 1, the topic 1, that is digital electronics, the number of hours allocated is 8 hours. So here we have to see the review of basic logic gates, derived logic gates, NOR, NAND, XOR and XNOR. NAND and NOR gate as universal gates, De Morgan's theorems, RS flip-flop, JK flip-flop, half adder, full adder and 4-bit parallel binary adder. In topic number 2, we have to study transistor amplifier and sinusoidal oscillators. In transistor amplifier, we have to see single stage common emitter transistor amplifier, DC and AC equivalent circuits, load line analysis, DC load line, AC load line and Q point. Under oscillator chapter, we have to cover feedback in amplifiers and its types, theory of feedback oscillator, percussion criterion for sustained oscillations, oscillatory circuit, essentials of transistor oscillator, sinusoidal oscillators like phase shift oscillator, Colpitts oscillator, Hartley oscillator, and crystal oscillator using transistors. Now let us consider the first topic from unit 1, that is digital electronics. So when you are teaching this topic, firstly you should introduce the topic to the students and take the review of this topic, because the students have studied some part of this topic in 12th standard or FY or SY. So you have to take into consideration that. So do not directly start with the derived gates. You should firstly introduce the student with the number system. So decimal number system, binary number system, octal number system, hexadecimal number system. What is the base of these systems? What are the symbols usually in these number systems? Particularly, we have to concentrate on binary number system, because when we are teaching this topic, we involve the binary number system. So give emphasis on binary number system. So tell the students what are the various symbols used in binary number system, that is 0 and 1, and what is the meaning of 0 and 1. So firstly, Tell them the logic symbols used in binary number system, then what is the meaning of 0, what is the meaning of 1. In some of the books, you may find that instead of 0 and 1, the word off and on is used. So tell them the meaning of 0, 1 in terms of voltage, in terms of on and off state. So this idea should be made very clear to the students. Otherwise, we teach this topic digital electronics, but if you finally ask the student what is the meaning of 0 and what is the meaning of 1, they are unanswered. So spend some time in explaining the binary number system so that the further understanding of the topic becomes very simple. Also, you try to write down at least the decimal numbers right from 0 through 9 in terms of binary. Because when we are writing a truth table, the student should know what is the meaning of truth table and how many possibilities are there in the truth table. So that should be made very clear in your introductory lecture. So write down at least the numbers, decimal numbers, right from 0 through 10, and use this binary weight method. So the weight of the binary digit is like this: 1, 2, 4, and 8. So any number can be written by using this table. So I want to write down 2, so I can write 1. Make the, because the total sum of these digits must be equal to your number. In this fashion, you have to write down the number. So at least you write down the numbers 0 through 10 so that this can be used in our further discussion. So when you are teaching logic gates, 1 minute. When you are teaching logic gates, give the definition of logic gate, explain the concept of logic gate with the help of the block diagram. That means the gate has some inputs, it has got output. So firstly, try to explain the logic gate by using the block diagram. Then discuss the logic gates with the following points. Keep in mind, when you are discussing the logic gates, use these points. So firstly, give the definition of logic gates, then write down the Boolean equation of that logic gate, then draw the logic symbol used in digital electronics. Then you should discuss about the truth table. Then you also discuss why we are taking only 4 states, why not any other? Because the number of possible states are 2 raised to 2, because 2 is the base or radix of the binary number system. And suppose the number of inputs are 2, then the number of possibilities or number of inputs must be 2 raised to 2, that is 4. So simply you have to write down the 4 numbers, decimal numbers 0 through 3. So in all 4, 0, 1, 2, 3. Then express these decimal numbers in binary fashion. So 0 is represented as 0, 0, 1 is represented as 0, 1, 2 is represented as 1, 0, and 3 is represented as 1, 1. So the inputs must be written in this order. Do not write down randomly, because these are nothing but the numbers 0, 1, 2, and 3. So you should always write down the inputs in truth table in this order. And tell the students these are nothing but 0, 1, 2, 3 in decimal way. Simply we have written here their binary representation. And then find out the output depending upon which type of gate you are going to use. So here I am using, or I am writing the truth table for OR gate, and therefore I have written the outputs in this fashion. Okay. Again, here tell the students what is the meaning of 0, what is the meaning of 1 in terms of the word off, or sorry, here there should be on, or in terms of voltage, that is when the state is 0, the output or input will be 0. When the logic state will be 1, the input and output will be plus 5 volts. So this idea should be made very clear to the student. So when you are discussing the first gate, discuss that gate in more details so that they can understand when you are discussing the remaining gates in this topic. Also tell them that these gates are available in ICs. So tell them something about the IC. What is IC? How many pins are there? The different IC packages like DAPE, SIP, TO99 package. Then there are the different series available in the market, that is TTL type of logic family or CMOS type of logic family. What is the difference between TTL and CMOS, etc. So don't restrict yourself only with the syllabus line, because I find that when the teachers are teaching, they simply concentrate on the syllabus lines. They don't go slightly away from the syllabus line, because whatever required for the understanding of that topic, that must be covered. So when you are teaching this digital electronics, don't directly switch over to the derived gates. The prior preparation of the student for understanding of the topic must be done. If you do this, then they can understand what is the actual digital electronics, what are the various devices used in digital electronics. They understood how to perform the practicals in the laboratory. So always try to relate theory with practicals. When you are discussing the theory part in the classroom, always try to link your theory part with the associated practicals which are to be performed in the laboratory. If you do the teaching in this fashion, then students will find to perform the practicals very easily. And also it will increase the interest of the student in that topic. So take care of this. Then you can discuss with the types of gates, means classification of logic gates. That is basic gates which they have already studied. And then from this curriculum, you have to start with derived gates. So when you are discussing the gates, use these points. So firstly, give the definition of that gate, then write down the Boolean equation, then write down the logic symbol for that gate, then write down the truth table and give one example of that gate. That is, which IC is available in the market in which we get this type of gates. Also, never made a mistake when you are teaching or when you are writing a Boolean expression. So when you are writing a Boolean expression, suppose for example, the first equation y is equal to A or B. So when you are teaching in the classroom, don't read like this, y is equal to A plus B. That is wrong, because you are not teaching a mathematics. You are teaching a digital electronics. So in digital electronics, the symbol plus means or. So you should read it like this, y is equal to A or B, and tell the student that the symbol plus represents the logical or operation. So this should be made very clear. When you are taking the second equation, y is equal to A dot B, you should read it as y is equal to A and B, because and is a logical operation, or is a logical operation, not is a logical operation, NAND is a logical operation, and NOR is a logical operation. So you should not read these equations simply as a mathematical equation. It has got a different meaning. So that should be made very clear with the students. So take the review of basic or fundamental gates in brief, that is and or not gates. Now our syllabus starts with the derived gates. So here I have explained one example. Firstly, give the definition, then write down the Boolean equation, then draw the logical symbol, then draw the truth table, then tell them how to write down these inputs 00011011, as I have just now told you that these are the decimal numbers 0 through 3 and total states are 4. Then tell them the example of this gate. So this gate is available in IC 7408. Tell the technical name of this gate, that is called a 2 input AND gate. Called means 4. and every gate has two inputs. So tell them that when you purchase the IC 7408 from the market, there are 4 gates inside this IC, their pin numbers, where the pins are available, where is the first gate, where is the second gate, where is the third gate, where is the fourth gate. Because this information should be given to the student as they have to perform practicals in the laboratory. So when you are performing the practicals, then they are able to understood why I should give the input at pin number 1, why should I give the input at pin number 2, why should I get the output at pin number 3. So this understanding of the student is very, very important. So when you are teaching the topic, always keep in mind that what type of practical I have to perform in the laboratory, so that your task during the practical will become a very simple. So discuss other gates on the same guideline. Again, you have to consider the derived gates NAND, NOR, XOR, and XNOR. Use the same guideline, definition, Boolean equation, symbol. I want to mention one point here. Don't discuss directly using the NAND symbol. That is the wrong way. So you don't consider the NAND gate symbol and explain the truth table of NAND gate. That is wrong, because this is a derived gate. And you should try to explain why it is called as the derived gate, because this gate is formed by using basic gates like and not, and not, because they have already studied the basic gates. So review of these basic gates is very important when you are teaching the derived gates. So firstly, take the review properly so that they can understood the remaining topic. So tell them how I can form a NAND gate by using basic gate, and not gate. And then write down what is the actual symbol used for representing the NAND gate when you are drawing the electronic circuit diagrams. So that understanding of the student must be made very clear. Then also give the truth table for this. Then read y is equal to complement of the AND. Y is equal to A and B complement. This fashion you should read the equation, then tell them in which IC that gate is available. So in similar way, you discuss about how to do practicals related with the gates. So spend some time and tell them when you are in the laboratory, we have to perform such and such practical, and this knowledge of theory is very useful to you when you are doing practicals in the laboratory. Now on similar guideline, you discuss NOR, XNOR gates, and discuss about how to do the practicals in the laboratory. Now then you have to verify the De Morgan's theorem. So when you are teaching De Morgan's theorem, give them firstly the statement of the De Morgan's theorem, explain what is the meaning of that, then write down the Boolean equation. Write down the Boolean equation. After writing the Boolean equation, you have to draw the actual diagram for this one. 1 minute. So write down the firstly the Boolean equation, tell them the statement, from statement, write down the equation, that is complement of the sum is equal to product of the complements. Then draw the logic diagram for the left hand side. Then draw the logic diagram for right hand side. And tell them that we have to show that the left hand side is equal to right hand side. Means both the gates are equivalent. So how to draw the logic diagram? That should be explained to the student. Don't by heart the logic diagram. So tell them that firstly we have to take the OR operation. So I have used the OR gate. Then I have to make the complement of this, and therefore I have used the NOT gate. And the right hand side, we see that complement of input A, the complement of input B. So that should be again shown here, complement of the input A, complement of the input B, and then I have to AND the two inputs. So I have used the AND gate, or this can be shown as bubbled AND gate, bubbled AND gate. So right hand side is bubbled AND gate, and the left hand side is NOR gate. Means the De Morgan theorem tells that the NOR gate is equivalent to bubbled AND gate. So in this way, you have to explain the logic gates, then write down the equivalence between the two, then see the proof for this De Morgan's first theorem. You can prove this theorem either by using the truth table. Here I have shown the outputs for the left hand side, outputs for the right hand side, or you may prove this by considering the different input conditions like A is equal to B is equal to, substituting this equation for left hand side, substituting the inputs for right hand side, and showing that both are coming same. So in this way, left hand side is equal to right hand side, and the law is verified. So in similar fashion, you can discuss the De Morgan's second theorem. Here also it is very essential to discuss about how to perform or how to use this theory for doing practicals, because we have to do practical related with verification of De Morgan's theorem and logic gates. So discuss this point also when you are teaching this topic in the classroom. Then you have to tell them about the laws of Boolean algebra, identities used in Boolean algebra. So these identities are very important. These identities can be very easily proved by writing a truth table. Then solve one example. So because in our skill experiments, we have to do one practical or a paperwork related with simplification of logical equation by using Boolean algebra. So in classroom, at least solve one example, then tell them to draw the logical diagram for that equation and tell them that how one can simplify or how one can reduce the number of gates involved in that by using the Boolean algebra. So that is the important advantage of Boolean algebra or Boolean identities. So one can simplify very complicated digital logic circuit. Then you have to discuss about why NAND and NOR gate are called as universal gates. So you tell them that by using NAND or NOR gate, the other remaining gates can be constructed. So NOT gate using NAND gate. You can also prove that. So you can prove this, how this AND gate acts as. And while giving the proof for this, you have to again use the De Morgan's theorem. So you can simplify this by using a De Morgan's two theorems. So in this way, you can tell them how one can construct any required gate by using either NAND or NAT gate as a basic building block. And therefore, NAND or NOR gate are called as universal gates. Then we have to discuss about the flip-flops. So give the introduction about the flip-flops. These are the memory blocks where we can store digital data, etc. Then you can discuss two circuits here. The first one is RS flip-flop using NOR gates. So draw the truth table, tell them the working, then also draw the logical diagram or logical symbol for RS flip-flop. So RS are the inputs, Q bar, what is the meaning of set, what is the meaning of reset, what is the meaning of Q bar, complement output, tell them about data. Similarly, you can discuss about RS flip-flop using NAND gates, truth table, etc. अर्चन हे मला काढता येईल का? 1 minute, please.
Sir, unmute yourself, sir.
So you can discuss, draw the diagram, draw the truth table, particularly here race condition. You concentrate on race condition, tell them what is the meaning of race condition. Data is not stable, unstable. So that is a very important condition and that is to be avoided in next part of the discussion. Then RS flip-flop. Then tell about the race condition and how one can avoid the race condition by using a D-type or T-type flip-flop. So here only we are using one line for data. When you make D is equal to 1, R becomes 1 and S becomes 0. When you make D is equal to 0, R becomes 0 and S becomes 1. So these two conditions will not come there, 0, 0 or 1, 1. They are avoided by using a D type of flip-flop. Then tell something about the clock, because the heart of the digital electronics is the clock. So tell the students what do we mean by a clock? What is the meaning of 1? What is the meaning of 0? How we can change 1, 0? How we can transfer the data 1, 0, 1, 0, etc. So this idea should be given to the student. So explain clock waveform, that is the square wave. Here also discuss about what is a positive edge triggering and a negative edge triggering. Because in some of the circuits, the data may be stored in the flip-flops during the positive edge. That is, this edge key is called as the positive edge and this edge is called as negative edge of the clock. So in digital electronics, some of the ICs or some of the gates may respond during the positive change 0 to 1. So this is called as the positive edge. In some of the digital circuits, the circuits may respond during the negative going edge of the clock. That means from positive to negative. This is called as the negative edge. This is called as positive edge. So this idea should be made very clear to the students. What is the frequency? And try to relate this with when I am using a mobile, that much frequency is given. When I am using a computer, the CPU speed is maintained like this. So what is the meaning of this? And then the student will understand how fast the data will be processed, and that depends upon the frequency of the clock. Then we have to discuss about the clocked RS flip-flop, how the synchronization of the data is possible with the help of the clock. So here the data will not be stored into the flip-flop unless and until there is a clock. So tell them, the students, what is the use of the clock, how we can synchronize the data. Suppose I have used 4 RS flip-flops and I have 4 data bits, suppose, and I want to latch these 4 bits simultaneously into these 4 flip-flops. Then I have to synchronize, and that synchronization is possible with the help of the clock. So tell them this idea about the clock. Then draw the waveform, because I find that most of the times the physics teachers are not drawing the waveforms, and that is wrong, because you are teaching a digital electronics and you should be able to draw the waveform. So here I have shown you how the above table for clocked RS flip-flop can be shown in terms of waves. And here I have shown that the change takes place during the positive edge. This line, see this line. And this is also very interesting. But we don't take the interest in doing all these things. For example, I will tell you the first thing, that is R is equal to 0, S is equal to 1, R is equal to 0, see. Here I have R is equal to 0 and S is equal to 1, S is equal to 1. And this change will take place when clock comes. During the positive edge of the clock, the status of the output will change. So here we see that S is equal to 1 and Q is equal to 1. And therefore you find that at this positive edge, The output goes from 0 to 1 and it remains in a 1. Q bar, that is the opposite state. So it is in the opposite state of this. Okay. And this data will remain as it is till the next clock pulse comes. When the next clock pulse comes, and suppose here R is equal to 1 and S is equal to 0. See here, R is equal to 1 during this clock pulse and S is equal to 0. So what is the output? The output will go to 0. So output has gone to 0 and it remains there. The output will change when the next pulse comes. So this idea should be given to the students. How the clock will decide the data stored in the RS flip-flop. So that will increase the interest of the students, and slowly they will try to think over this, how the computer will work, how the data will be switched in the computer. So this is very clear if you draw the waveforms. So at least draw waveforms and tell them, give different conditions and draw the waveforms. They can play with the waveform and their interest will increase. Then you have to discuss about the JK flip-flop. Tell them about the last thing, that is what is the meaning of toggle. So these conditions should be explained to the students very well. This is just like as RS flip-flop, but this is a very important condition available in the JK flip-flop, toggle mode. Give one example like caps locks on the keyboard. Caps locks on the keyboard and num lock on the keyboard. Because we see that, suppose initially the caps lock is off. When I press that caps lock on the keyboard, it becomes on. If I again press caps lock, it becomes off. And this operation is called as the toggle mode. If it is on, then it becomes off. If it is off, by pressing the same key, it becomes on. So this operation is called as a toggle mode. So here the best example is caps lock and num locks available on the keyboard of the computer. So they should understood why one should use this sort of flip-flop. JK flip-flop will do that work. Then draw the logic symbols for this JK flip-flop. So this is the simplest one, figure A. In figure A, we have provided two more inputs like preset and clear. So without using J and K, you can store data Q and Q bar depending upon preset. So if you make positive preset high, make it 1, Q will become 1. If you become clear, that is equal to 1, the Q will become 0. So you can store a preset or predefined data into the flip-flop. You can clear the data stored in the flip-flop by using this preset and clear. So this has got more priority as compared with J and K. So this is a positive edged clock pulse and this is a negative. See this bubble. So this bubble indicates the NOT operation as in our gates also. So this point should be made very clear to the students so that when they are reading the books, reference books, they come to know that what is the meaning of these symbols. Now we switch over to binary arithmetic. So the first one, that is half adder. So firstly introduce them with how the binary addition is done, how the binary addition is possible. So tell them about the rules of this binary addition. 0 plus 0, 0, 0 plus 1, 1, 1 plus 0 is 1, and 1 plus 1 is not 2. Because we are not working in decimal number system. We are working in binary number system. And in binary number system, when we add 1 with 1, actually result is 2, no doubt. This is a decimal number. But we have to write down this binary 2, decimal 2 in binary as 1, 0. As 1, 0. And therefore, 0 is sum and 1 is carry. So this should be made very clear to the student. So that is I have written here also. So this last case is very important. When you add binary 1 with 1, the result is not 10, result is 1, 0. Result is 1, 0. 0 is a sum and 1 is carry. So this is also represented here in the truth table. So ask a student firstly the questions, how I can form the carry bit by observing the inputs and outputs. So we come to know that here this is similar with the truth table of AND gate. And here we find that this is similar with truth table of XOR gate. So we can implement the half adder, have two inputs, A input, B input, these are the inputs. And by using the AND gate, we can generate a carry, that is A and B. And by using this XOR gate, we can generate the sum A bar B plus A B bar. So this is the Boolean equation for XOR gate. So in this way, you can explain. Again, here you have to again concentrate on the practicals, because we have to perform practicals related with half adder and full adder. So again, give the reference to the students that we have to use this theory in the classroom, or we have to use this theory when we are in the laboratory, because we have to perform one practical related with half adder. You draw the logic symbol for half adder. It has got two inputs and it has got two outputs, and the outputs are nothing but one is sum and another one is carry. Because this is very explained very well, because we have to finally write down the parallel adder. And if you want to understand the parallel adder, you should be very clear with the half adder and full adder. Unless and until your understanding of half adder and full adder is clear, you cannot design a parallel 4-bit binary adder. So this is about the full adder. So explain the students about how we perform the decimal addition. So I have taken here a decimal number and perform the addition of this. So 6 plus 4, 10. So sum is 0, carry is 1. 6 plus 3, 9 plus 1, 10. 0 is addition, 1 is carry. 5 plus 5. In this way, you explain how we perform addition in decimal. So similarly, switch over to binary and tell them how we perform the binary addition. So here we have considered the two binary numbers 101, 111. So firstly, I add these two bits, 1 plus 1, using the binary rule, 1 plus 1. The sum is 0 and carry is 1. So 0 plus 1 is 1, 1 plus 1, that is 1, 0. So again, I get the sum 0 and carry 1. So in this way, explain the students how we perform the binary addition, so that they come to know that whether I require a half adder, whether I have to use a full adder. So here we see that in the first column, we are adding the 2 bits, and this is possible by using a half adder. So when I switch over to the next column, I have to add 3 bits, and 3 bits addition is possible with the help of full adder. So when I add these numbers, I require a full adder. So this is the design for full adder. Explain them. Decimal values. Here there are 3 inputs. So 2 raised to 3, that is 8. So 8 possibilities are written serially, 0, 1, 2, 3 up to 7. Then I have converted these decimal numbers in binary. So don't write randomly. Write down these truth table inputs in a serial fashion, 1, 2, 3, 4, 5, 6, and 7. Convert these decimal numbers into equivalent binary numbers, and then find out what are the carry bits, then what are the sum bits. And by observing this table, we come to the conclusion that the carry bit is generated by sum of outputs of AND gates. So this is the logic diagram for the full adder, and the sum bit is generated by using 3 input XOR gate. Then this is the circuit symbol or logic symbol for full adder. It has got 3 inputs And out of 3 inputs, the 2 are bits and the third one is a carry generated by the previous column. And this will again yield or generate a carry bit and a sum bit. So tell them very clearly the half adder, full adder, so that they are able to design a 4-bit parallel binary adder. So parallel means we are adding the 2 numbers parallelly. Here the first binary number is A0, A1, A2, A3. So these are the bits. A0, A1, A2 are the 4 bits of the first number. Similarly, we have the second number, B0, B1, B2, B3. These are the bits of the second number. Now see, now we have to use the binary addition rules and add them. So in the first column, what do we find? There are only 2 bits. In first column, we have only 2 bits, A0 plus B0, that gives you some bit S0 and it generates a carry C0. Okay. So here we have to add 2 bits and therefore I am using a half adder. This has got the 2 inputs, A0 and B0, and it will generate the sum bit S0 and carry bit C0. Okay. Then when I switch over to the next column, I have to add now 3 bits. A1, B1, these are the bits from the number, and C0 is the carry generated by the previous column. So this is possible by using a full adder. See, A1, B1, these are the bits from the number, and C0 is the carry coming from the previous column, and that is added with the bits, and it will generate the sum S1 and a carry C1. So in this way, you can go further. Every time we are adding 3 bits, therefore we require full adders to perform the sum in the next column. So we require 1 half adder at the unit position, and then we have to use full adders to perform the addition of remaining bits. So you can design n bit. You ask the student how one can add n bit binary number and how many I require a half adder and how many full adders are necessary. Ask the question to the students. If you teach this very clearly, they can surely answer your question. So this is all about digital electronics. Try to make the interest amongst the students related with digital electronics. Okay. Then second topic is a transistor amplifier and sinusoidal oscillators. 10 hours are allotted to this. In amplifier, we have to study single stage C amplifier. We have to study the DC and AC load lines. So before going to start this topic, firstly give some introduction. Tell them what is an amplifier, what amplifier does, what is the phase difference, what is the phase difference between input, output, etc. So this idea should be given to the student. Draw some waveforms. As we are discussing about sinusoidal, so consider the input as a sine wave and see how the amplitude of the output wave increases. Then give the this classification to the students so that they come to the understood that there are different types of amplifiers available in the market. All amplifiers are not identical. So the cost of the amplifiers is different depending upon its classification. Tell them what is the difference between a public address system and a Dolby system. So you can try to increase the interest among the students by giving some references, practical references, so that they understood that the physics is very important. This is a applicable circuit, applicable subject. And in this way, you can try to increase the interest of the students. Tell them about the Q point. Because when you are going for class A, class B, class AB, class C, that is basically related with how you are selecting the operating point on the output characteristic curve. Then you have to discuss about the single stage common emitter amplifier. Tell them about the function of each component connected in this circuit. Then you have to draw So this is the left hand side is the single stage. Why it is called as the single stage? What is the meaning of two stage? What is the meaning of cascading? So these words should be given to the student so that they can understand how I can increase the gain of the amplifier by using multiple stages. So that idea should be given to the students. Then tell them how we can perform the analysis. So here we have to discuss the graphical method of analysis of amplifiers. So here you have to first tell them what is the meaning of AC, what is the meaning of DC. Both the sources are working in amplifier. So for the working of the amplifier, we have to give the DC supply between plus VCC and ground. And the signal which we want to amplify, that is a AC signal, and that is given to the amplifier through the coupling capacitors. And we get the output at the collector. Again, we require a coupling capacitor. So this idea should be given to the students and then tell them we want to perform analysis or we want to have the design of the amplifier. So the designing of the amplifier is also possible by using a graphical method. Instead of using an analytical or mathematical equations, you can simply draw the characteristics of the amplifier and design or see the performance of the amplifier. So that is the idea of the graphical method of analysis. So you first discuss about DC analysis, how we draw the DC equivalent circuit. So reduce all AC sources to 0, open all the capacitors, and suppose we apply these two conditions to this figure 1, then what will remain? And that is nothing but the DC equivalent circuit of the amplifier. Then write down the expression for base current and discuss briefly regarding the DC analysis. Also draw the equivalent circuit of the amplifier by using AC. So we have to remove now AC signals. Capacitor should be shorted. So apply this condition and draw the remaining circuit of the amplifier. And this is nothing but the AC equivalent circuit. Then draw the IV characteristics. Then write down the equation for this outside or output part. Use Kirchhoff's law and write down the circuit equation. This equation is here. And find out the equation for IC, because here we are plotting the graph of IC and VCC. So I have saw this equation for IC. Use this equation with y is equal to mx plus c and tell them that what is the slope of this straight line, because this equation represents the equation of straight line. IC is equal to minus VC upon RC plus RE minus negative slope. And therefore this straight line is drawn in this way, which has a negative slope. Then you tell them that what is the slope of this straight line, what are the intercepts on the x-axis and y-axis. Discuss all these points here. Why this is called as the load line, as the slope of this straight line is decided by the load resistance, and therefore this is called as the load line. And whatever analysis we are going to do is called as load line analysis. Then also similarly you can draw the AC load line. So here AC we have considered effect of DC as well as AC. So this equation is written by considering the overall effect of DC and AC. Okay, so in this way you have to briefly discuss about AC load line, DC load line. This is the AC equivalent circuit for the single stage amplifier, how it is drawn. These conditions are given here. So this is about the transistor amplifier. Now the sinusoidal oscillators. So firstly, the syllabus is feedback in amplifier and its types, theory of feedback oscillator, Barkhausen criterion for sustained oscillations, oscillatory circuit, usually it is called as a tag circuit, essentials of transistor oscillator, sinusoidal oscillators, that is, we have to see phase shift, Colpitts, Hartley, Crystal. Now, firstly discuss about feedback in amplifier. Tell them what we mean by the feedback, give the definition of the feedback. Then tell them that there are two types of feedback, that is the positive feedback and negative feedback. So explain this positive and negative feedback with the help of this waveform. Tell them about the phase, positive, positive in the same phase. The addition of the input will take place. Similarly here, the negative feedback, you tell them about the waveforms. So here we see that these two waves, the input signal and the feedback signal, there is a phase difference of 180 degree. So they are opposing, and therefore it is called as negative feedback. So explain this with the help of this block diagram. Then tell them something about what is the difference between oscillator and amplifier. So this is a very important point to be discussed with the students, because when we take the oral during our practicals, we find that the student is unable to answer some simple basic questions, and that is because of we don't tell him. So I request all the teachers to give emphasis on the difference between amplifier and oscillator. So I don't discuss with this, because the amplifier requires an input signal always, but oscillator does not require an output signal. It simply converts DC power into AC power, and this principle is used in the inverters which we are using in our houses. Then tell them about the various waveforms used in electronics: sine wave, square wave, triangular wave, sawtooth waveforms, because all these waveforms are involved in electronics. They have got different applications. So tell them about at least the shapes of the waveforms. Then discuss about oscillations in tank circuit, how we can produce electrical oscillations. In our general physics experiment, we can produce oscillations of a simple pendulum. And we see that the amplitude of simple pendulum go on decreasing as time passes. Or if we plot the graph of amplitude of the physical oscillations with time, we get a sine wave, but we see that the amplitude goes on decreasing exponentially. So tell them that we now want to produce the electrical oscillations, not a physical like simple pendulum. So discuss this LC tank circuit. What is the meaning of tank circuit? So parallel circuit of inductance and capacitance is usually called as a tank circuit. So discuss them when we initially charge the capacitor and we discharge the capacitor through inductance, how the current will change, how the magnetic field will change, electrical energy from capacitor is converted into magnetic energy around the coil. When the current becomes zero, current collapses, Faraday law comes into play, induced EMF generated, again the capacitor charges in the opposite side, etc. So in this way you explain charging, discharging of capacitor through inductance. And finally, we see that the charging and discharging current is slowly gone decreasing, and finally it becomes zero. And therefore, these sort of oscillations, electrical oscillations, are called as damped oscillations, and the frequency of oscillation is 1/2 pi root LC. So this damped, this point must be given emphasis so that they can understood why we require an amplifier, why we require a phase shift network when we are designing an oscillator. So here we should note that the oscillations which we are getting in a tank circuits are damped oscillations, amplitude is decaying, and if we want to have the sustained oscillations, then we must supply the energy. And so we require an amplifier, we require a proper phase. So this understanding will be very clear when you are discussing the further part of the topic. Then we have to discuss about theory of feedback oscillators. Here we have to consider the block diagram. We have to consider expression for gain of amplifier with feedback. Then discuss different cases depending on feedback factor beta, the percussion criterion for sustained oscillation. So firstly, draw the block diagram. I have shown here amplifier with gain A, and we have the feedback network. So find out the expression for feedback gain AF, that is V0 by Vs, that is A upon 1 minus A beta. And then discuss three cases when beta is equal to 1 and positive, beta is negative, and when A beta is equal to 1. So that condition A beta is equal to 1, we get the gain of the amplifier infinite. And the meaning of this is that gain is equal to output of input, and gain is infinity, means the input is 0. 1 upon 0 is infinity. Means this circuit gives infinite output, or the gain of the amplifiers becomes input, even though there is no input. And this circuit is nothing but oscillator, which we have studied previously, the difference between amplifier and the oscillator. So try to relate this. So they should understood why A beta should be made 1. Beta is positive and the product A beta should be equal to 1. So we get the overall gain, feedback gain equal to infinity. At that time, the circuit start working as oscillator, or it start producing the output waveform without giving input. So try to explain all these things. Then essentials of transistor oscillator, because in tank circuit we have seen that the oscillations are damped oscillations, and if we want to have the sustained oscillations, then we require a transistor amplifier, and we have to supply the energy back to the tank circuit. Whatever amount of energy is lost, that much amount of energy must be supplied to the tank circuit. And for this purpose, if we consider the block diagram of or essentials of transistor oscillators or requirements of transistor oscillator, these are nothing but a tank circuit, a transistor amplifier, feedback circuit, and their feedback must be positive. Again, you have to satisfy the Barkhausen condition, E beta must be equal to 1. Then this will give a sustained oscillation. We have to discuss about sinusoidal oscillators. So when you are discussing these oscillators, firstly draw the circuit diagram, then give the circuit operation, then obtain expression for frequency of the oscillator, then give some advantages of that particular oscillator, some disadvantages of circuit. So by considering these points, you have to discuss about the following oscillator circuits like phase shift oscillator, Kolhapur oscillator, Hartley oscillator, and crystal oscillator. So example given here, draw the circuit, firstly give the circuit description or circuit operation, then expression for frequency, advantage and disadvantage. So in this way, you have to discuss all these oscillators. Finally, make the comparison between the oscillator circuits. So here we see that the amplifier section and feedback section remains the same, only the tank circuit. So in Kolhapur oscillator, there is a split capacitor. In crystal oscillator, we are using crystal instead of inductance. And in Hartley oscillator, this is a split inductor oscillator. So try to make the comparison so that the students can remember these circuits. Amplifier circuit remains as it is. So simply you have to remember what is the tank circuit for that particular oscillator. These are the reference books which are already given in your syllabi. Digital Principles and Applications, Malvin and Leach is the best book. Fundamentals of Digital Circuits, Anand Kumar. You can also use Electronic Principles by V.K. Mehta, Basic Electronics by Bhargava and Gupta. So you can use these reference books. Tell the students to go through all these reference books. At least once you bring your students to the laboratory, go with the students to the laboratory, open some of the reference books, show them so that the students can know that a lot of information is available in the reference books as compared with textbooks. Myself, I bring the students to the library. I go to my physics cupboard, take few books from the cupboard and show the students that, see how much descent diagrams are available in our reference book, how they have given the explanation. They have also given information about the scientist. So show all these things to the students so that they can see the reference books. Otherwise, we teachers as well as students are always following only the textbooks in which there are so many errors. So try to bring the attention of the students towards the reference book. Now, whatever I have discussed, particularly from digital electronics, you can go through all these videos because I have put all these videos on my channel, Dr. V.V. Killedar. So there are more than 25 videos related with physics topics. So I request all the teacher participants to visit my channel and see the videos I have uploaded on this my channel. So particularly related with the digital electronics, there are a number of topics I have discussed, and all these videos are available on my channel, Dr. V.V. Killedar. So I request all of you to register, subscribe the channel, and you can also see all these topics through my videos. So with this, I conclude my discussion. If you have any doubts, then you can ask me. Net cut झालं का?
Hello.
हाँ बोला.
Hello.
Hello.
Thank you, sir, for your nice presentation. Because you have very good experience in electronics, and whenever there is a board of studies meeting, Dr. Killedar insists about the syllabus, electronics syllabus to be included in the syllabus, and that is how it shows its interest in his interest in electronics. So thank you for your nice presentation, because you have discussed all the things thoroughly in this unit, digital electronics, transistor amplifiers, and sinusoidal oscillators. I request participants, if there are any doubts or queries regarding this unit, they please are requested to raise the queries so that we have discussion on this platform. So we will spend a couple of minutes for the discussion. If the participants have any queries or discussion, please raise your queries one by one. Hello.
त्यांच्या अनम्यूट काढायला लागतील ना.
हा, ज्यांना काय शंका असेल तर
अनम्यूट काढता येईल. अनम्यूट करा एक मिनिट सगळ्यांना.
अनम्यूट करा विचार.
निमत सर,
हा,
मला एक प्रश्न होता.
बोला. येस सर.
म्हणजे प्रश्न म्हणजे आता किल्लेदार सरांना प्रश्न म्हणण्यापेक्षा असं सजेशन करायचं होतं की सरांनी जे लॉजिक गेट सांगितले अतिशय चांगलं, मी रिव्हिजिट केलं ते सगळं, मी जे सुरुवातीला शिकलो होतो ते, आणि मला आणखी मी पूर्ण लेक्चर ऐकलं सर किल्लेदार सर तुमचं, अतिशय सुंदर तुम्ही लेक्चर.
थँक्यू सर, थँक्यू.
आणि मला असं वाटतं की तुम्ही ह्या ज्या पॉवर प्लांट तयार केलेल्या आहेत त्या आपल्या सगळ्या शिक्षकांना उपलब्ध करून द्याव्यात, आणि म्हणजे माझं एक पर्सनल सजेशन आहे.
हो द्यायचं.
आणि हे जे आता रेकॉर्डिंग झालं तर तुमच्या लेक्चरचं, त्याचं कट करूया आपण ते, आणि मग ते एक लेक्चर दॅट विल बी म्हणजे कोर्स मटेरियल असं होईल. पण फार सुंदर तुम्ही सर लेक्चर घेतलं. मला असं वाटतं की लॉजिक गेट सांगत असताना मी माझ्या विद्यार्थ्यांना, यात माझे बरेचसे विद्यार्थी दिसतात शिक्षक, तर त्यांना मी हा प्रश्न विचारला होता नेहमी की 2 इनपुट लॉजिक गेट आहे, 3 इनपुट लॉजिक गेट, म्हणजे नंबर ऑफ इनपुट्स वाढवल्यानंतर मल्टी इनपुट लॉजिक गेट ही जी आहे ना, ते मुलांना स्पेक्युलेट करायला सांगायला पाहिजे. तुम्ही एक फॉर्म्युला लिहिला होता, नंबर ऑफ 2n चा काहीतरी फॉर्म्युला होता. तर ते एक गोष्ट करावी. आणि जसं तुम्ही आयसी एक दाखवला होता आणि त्याच्यामध्ये गेट्स दाखवले होते, अशा पद्धतीने थोडंसं ऍडव्हान्स्ड मटेरियल्स, म्हणजे भले ते आपल्या करिक्युलमच्या बाहेरचं का असेना, पण त्याच्याशी रिलेटेड मुलांना आता मायक्रो प्रोसेसर पर्यंत नेण्यासाठी ह्याचं कसं ताळमेळ लावता येईल, ह्या गोष्टी सांगाव्यात असं मला वाटते.
ते गरजेचं आहे सर.
ते गरजेचं.
तरच मुलांचा इंटरेस्ट वाढतो, तरच मुलांचा इंटरेस्ट वाढेल. नाहीतर ते हवेतच असतात. 1 आणि 0 त्यांना कळलेलंच नसतं. ते म्हणतात नुसतं 1 0. त्याचं फिजिकल मिनिंग जे आहे, व्हॉट इज द फिजिकल मिनिंग ऑफ 1 and 0, दे डोंट अंडरस्टूड.
अगदी बरोबर.
दॅट शुड बी मेड व्हेरी क्लिअर. ऑन ऑफ 5 व्होल्ट. So what is the positive logic, negative logic? So these concepts should be made very clear. Otherwise, they are unable to do the practicals.
म्हणून मला सांगायचं असं की मी मगाशी सांगितलं माझ्या टॉकमध्ये की मुलांना आहे का नाही परीक्षार्थी बनवण्यापेक्षा विद्यार्थी बनवायला पाहिजे. मुलांनी प्रश्न विचारला पाहिजे स्वतःला आणि त्या स्वतःच्या प्रश्नाची उत्तर स्वतः मिळवायला पाहिजे. ही गोष्ट कधी होऊ शकते तर ते त्याच्यासाठी हे एक्झाम्पल मी तुम्हाला सांगितलं. 2 इनपुट लॉजिक गेट वरून 3 इनपुट लॉजिक गेट कसं असू शकेल हे मुलांना स्वतःला आपण सांगायचं नाही काय. आपण फक्त त्यांना हिंट द्यायच्या आणि
किंवा डेटा बुक काय असतं हे कुठं बघायचं असतं हे त्यांना सांगायला पाहिजे की डेटा बुक उघडा, मग याचे सगळे डिटेल्स तिथे अवेलेबल असतात. पिन कॉन्फिगरेशन दिलेलं असतं, आत गेट कसे ठेवलेत हे तिथं दाखवलेलं असतं. हे कधीतरी सांगायला पाहिजे. पण सर सरांची
मेमरी जी आहे ना, मेमरी जी आहे, मेमरी डिव्हाइसेस जी आहे, ह्या मेमरी डिव्हाइसेस पर्यंत ह्या लॉजिक गेट किंवा तुमचे फ्लिपफ्लॉप्स तिकडे कसे जातात हे थोडंसं कोरिलेशन शिक्षकानं त्या ठिकाणी एक्सप्लेन केलं सांगत असताना. थोडंसं आउट ऑफ सिलेबस जाऊन नुसतं इंट्रोड्यूस करायला काय हरकत आहे.
इंट्रोड्यूस करा म्हणजे प्रत्येक टॉपिकची जी तुमची इंट्रोडक्शन आहे ती प्रॉपर असली पाहिजे.
एक्झॅक्टली.
तरच त्या टॉपिक मध्ये मुलाला इंटरेस्ट निर्माण होतो. तुम्ही डायरेक्ट तुमच्या डिजिटल डिराइव्हड गेटला जर जाऊन शिकवत असाल त्या पोराला टॉपिक कळणारच नाही.
अगदी बरोबर, अगदी बरोबर.
म्हणून थोडा वेळ एक्स्ट्रा दिला पाहिजे.
प्रत्येक शिक्षकानं पार्श्वभूमी ही सांगायलाच पाहिजे आणि तुम्ही अतिशय चांगल्या पद्धतीनं लेक्चर तुम्ही
पण इथं उत्तर काय असतं माहिती आहे शिक्षकांचं सर की आम्हाला ते 45 तासात संपवायचं आहे, पण कृपया असं म्हणू नका ज्यादा तास घ्या 4 आणि शिकवा.
अगदी बरोबर.
पण हा एक माझी रिक्वेस्ट, हंबल रिक्वेस्ट आहे सर्वांना की आपल्या फिजिक्सला मुलं येण्याची संख्या कमी असते आणि ती जर आपल्याला वाढवायची असेल तर थोडासा आपल्यालाच त्रास काढावा लागेल. आपल्याला मुलांच्या मध्ये इंटरेस्ट निर्माण करावा लागेल आणि तो जर केला आपण तर नक्कीच तुमच्या विभागाला विद्यार्थी कमी पडणार नाही. म्हणजे माझं छोटं कॉलेज असून सुद्धा आज आमच्याकडे एकच FY डिव्हिजन आहे, पण 15 मुलं माझ्या आता टीवायला आहेत, हे लक्षात घ्या.
बरोबर आहे. मला या अनुषंगानं असं सांगायचं आहे की सगळ्या शिक्षकांना, आता बरेचसे शिक्षक टोनपे सर दिसत आहेत, पुन्हा शिंदे सर आहेत किंवा बोबडे सर आहेत, सगळेच ही जी सिनियर मंडळी आहेत त्या सगळ्यांना असं सुचवायचे मला की हे जे आपण 4 वर्कशॉप घेतोय, म्हणजे अर्थात मला थोडस मी हे करणं बरोबर नाही कारण त्या विषयाची
बोला सर, बरोबर आहे तुमचं सांगताय ते. बोला
सर. वर्कशॉप त्यासाठीच आहे आपलं.
वर्कशॉप सर तुमचा गायडन्स आवश्यकच आहे सर तुमचा.
मी गायडन्स कशा अर्थाने करणार आहे हे मी सांगतो. आता जसं सरांनी आता सर फार मला मी ते गुरु आहेत मला कुल्लेदार सर, तर इलेक्ट्रॉनिक्स आणि ह्या गोष्टी म्हणजे बऱ्याचशा आम्ही शिकलोय त्यांना, म्हणून मी ही केलं नाही. परंतु उदाहरणार्थ मी जे विषय शिकवलेले आहेत इथे MSc ला त्या ह्या मुलांना शिकवलेले आहेत की जे आता शिक्षक आहेत, तर त्याच्यातील काही भाग मला म्हणजे माझ्या कीनोट ऍड्रेस मध्ये मी घालणार आहे उरलेल्या 3 वर्कशॉप मध्ये.
बरोबर,
असं मला असं वाटतं.
नाही ती गरजेची गोष्ट आहे. आणि एक गोष्ट आपण करूया की विद्यापीठातला फिजिक्स विभाग आणि आमचे कॉलेजमधले डिपार्टमेंट याच्यामध्ये एक आपण चांगलं रिलेशन डेव्हलप करूया. कारण विद्यापीठातल्या तुमच्यासारख्या हेडने आम्हाला गायडन्स केला पाहिजे. आणि कारण शेवटी कसं आहे की हा जो आमचा UGचा जो प्रॉडक्ट आहे तो तुमच्याकडे PG ला येतो आणि म्हणून आपल्या दोन्हीमध्ये एक सामंजस्य चांगला असेल तर मला वाटतं आपण नवीन नवीन गोष्टी आपल्या विषयासाठी चांगल्या पद्धतीनं करू शकू.
अगदी बरोबर आहे सर. तुम्ही मला पर्सनली भेटला होता तेव्हा सुद्धा सांगितली होती ही गोष्ट. आता ह्या सगळ्या गॅदरिंग समोर पण मी ती सांगतो की बाबा पास्ट इज पास्ट, आता आपण नव्यानं सुरुवात करायची आहे. आणि हे जे सगळे गॅदरिंग मला दिसतंय याच्यामध्ये माझे शिक्षक आहेत, माझे सहकारी आहेत, माझे विद्यार्थी आहेत. मग ह्या सगळ्यांच्या मी प्रत्येक बॅचच्या अतिशय जवळ होतो आणि तुम्हाला ही गोष्टी लक्षात येत असेल. आता 1.5-2 महिने होऊन गेले तरी बरेचसे विद्यार्थी आहेत, माझे विद्यार्थी आहेत, माझं अभिनंदन करायला इथे आता विभाग प्रमुख पद मिळालं, आता BOA चेअरमनशिप मिळाल्यानंतर परत सर सुरुवात झाली. मला सांगायचं हे की मी अतिशय चांगल्या पद्धतीनं आपल्या शिक्षकांशी, आपल्या विद्यार्थ्यांशी, माझी विद्यार्थ्यांशी जोडलेलो आहे. आणि म्हणून आपल्या जसं तुमच्या डोक्यात आहे किल्लेदार सर की बाबा आता इथून पुढे कॉलेजच्या शिक्षकांना विश्वासात घेऊन की सिलेबस इम्प्लिमेंट करत असताना, टीचिंग इम्प्लिमेंट करत असताना, कार्यशाळा घेत असताना आपला हा अतिशय चांगला समन्वय असेल, हा माझा शब्द आहे.
ओके, थँक्यू सर. थँक्यू.
थँक्यू.
Thank you, Dr. Rajpure sir, for your comments and that you said that we should teach beyond our syllabus, and that is good suggestion. Definitely our teachers will accept that suggestion. If there is any other query, then please ask, otherwise we'll go to the next invited talk.
ओके. आणि माझी सर्वांना विनंती आहे सर्व शिक्षकांना की तुम्हाला केव्हाही जरी प्रॉब्लेम आला तरी तुम्ही मला 11th आवरला जरी फोन केला तरी हरकत नाही. माझा फोन मी कधीही बंद ठेवत नाही. 24/7 माझा फोन चालू असतो. तुम्ही कधीही मला रात्री फोन केला तरी मी फोन उचलणार, याची पण मी तुम्हाला गॅरंटी देतो.
ओके, थँक्यू डॉक्टर केलेदार सर फॉर युअर नाईस प्रेझेंटेशन.
एक मिनिट, मला अजून एक असं विचारायचं होतं की आता परवाचं वर्कशॉप बघितलं तर त्याच्यामध्ये बोबडे सर सांगतील 100 पेक्षा जास्त पार्टिसिपंट्स होते. आजचं जर वर्कशॉप बघितलं तर मला वाटतंय एक 50 पेक्षा कमी दिसत आहेत पार्टिसिपंट. असं काय का त्याच विषय शिकवणारे शिक्षक असं आपण बोलवलंय का?
नाही, असं नाही. सर्वांना ओपन आहे. आता खरं तर ऑनलाईन आहे, त्यामुळं जवळजवळ 100% लोकांनी ते ऐकणं आवश्यक आहे.
नाही सर, आपण बोर्ड ऑफ स्टडीच्या सगळ्या मेंबर्सनी काय करायला पाहिजे, मी त्यासाठी बोर्ड ऑफ स्टडीच्या व्हॉट्सअप ग्रुपवर लिंक टाकली होती. बऱ्यापैकी बोर्ड ऑफ स्टडीचे मेंबर आहेत, तर सर्व शिक्षकांनी हजर राहावं आणि मार्गदर्शन करावं असं मला वाटतं.
नाही, गरजेचं आहे.
बरोबर.
कमी काय आहे?
नाही, आता मला वाटतं इथून पुढे विद्यापीठानंच एखादं तसं सर्क्युलर पाठवावं कॉलेजला सर्व शिक्षकांना.
नाही, ह्या फोरमवर मी सगळ्यांना सांगतो, तुमच्या ज्या कॉलेजचे शिक्षक हजर सगळ्यांना निरोप द्या. दुपारी जर लेक्चरला हजर राहिले तरी चालेल. इथून पुढे अजून 3 वर्कशॉप आहेत.
बरोबर.
आणि अशी एवढी अवस्था नाही पाहिजे मला वाटतं.
आणि मी सुद्धा अपील केलेलं होतं ग्रुपवर की ज्या सर्व सिनियर शिक्षकांनी आपल्या डिपार्टमेंटच्या सहकार्यांना हजर राहायला सांगा.
बरं का सर, तर ते मला जाणवलं परवा दिवशीच्या वर्कशॉपला बऱ्यापैकी किती होते पार्टिसिपंट?
एमएससी थोडं ऑफलाईन आहे, बाकी सगळं बंद आहे.
65 विद्यार्थी होते. 65
नाही पार्टिसिपेट झालेले 100च्या आसपास होते आणि ऍक्च्युअली 65 ची सुरुवात होती.
आकडा जास्त होता, थोडक्यात
आकडा जास्त होता.
बरं का, आपण सगळे बोर्ड ऑफ स्टडी मेंबर इथं आहोत, सगळ्यांनी ही गोष्ट करायची आहे. बरं का, टोनपे सर, सचिन आहे, किल्लेदार सर आहेत, टीजे शिंदे आहेत.
ओके,
तर आपण सगळ्यांनी ही गोष्ट नोंद घेऊया की सर्व कॉलेजचे शिक्षक नाही आहेत.
बरोबर.
आणि हे आम्ही सगळ्यांना सूचना मी करेन ऍज अ चेअरमन ऑफ बोर्ड ऑफ स्टडीज की सगळ्यांनी, जर तुम्हाला ऑनलाईन फॅसिलिटी असेल, तुम्हाला प्रवास करायचा नाही, तुम्हाला रजा टाकायची नाही, फक्त तुम्हाला मोबाईल चालू करायचा आहे किंवा तुमचा लॅपटॉप उघडायचा आहे आणि 1-2 तास द्यायचे. आणि काही दररोज ठेवलेलं नाही आपण हे लेक्चर्स.
नाही, यायला पाहिजे ना, हे बघा किती अप्रोच बरोबर.
पण या गोष्टीची मी नोंद घेतली सर.
नाही, याच्यावर काहीतरी करावं लागेल कार्यवाही.
नाही सर, तुम्ही काय करा सर, ऍज ए चेअरमन म्हणून सर तुम्ही खरं म्हणजे काय तर असं एक सर्क्युलर काढा कॉलेज टीचरसाठी.
नाही, सर्क्युलर आता ते काढताच येईल, मी ते काढतो, परंतु आता सुद्धा ह्या फोरम मधनं सगळ्यांना मेसेज जाऊ दे.
हॅलो
किल्लेदार सर, मला त्या ग्रुपमध्ये ऍड करा शिक्षकांच्या.
हो.
हॅलो किल्लेदार सर.
हा, बोला.
हा, मी डॉक्टर गंगावणे बोलतोय.
हा, बोला सर.
हा, या संदर्भात आता मला एक 2-3 विद्यार्थी आहे टीचरांचे मला फोन आले होते, आमच्याकडे लिंक नाहीत असे म्हणत होते. तर जे नॉन ग्रॅज्युएट कॉलेजेस आहेत त्यांच्याकडे अजून बऱ्याच जणांच्याकडे लिंक गेलेली नाही, असं एक त्यांच्याकडून आलंय.
सॉरी टू डिस्टर्ब यू सर, ऍक्च्युली जे कोल्हापूर, सांगली, सातारा जिल्ह्यातील सगळे कॉलेजेस आहेत, प्रत्येक कॉलेजेसना आम्ही मेल केलेला आहे सर, लिंक शेअर केलेली आहे.
एक मिनिट. आणि दुसरा असा आहे, ते आपला SUK ग्रुप आहे,
हो सर, त्या ग्रुपवर
सगळे जॉईन आहेत ना, त्या ग्रुपवर 3-4 वेळा लोकांनी टाकलेला आहे.
एक मिनिट, मला जे आता आला ते आम्ही त्या ग्रुपवर नाही असं मला नाही आला त्यांचा मेसेज.
हे बघा, मी फिजिसिस्टला टाकलेला आहे, फिजिसिस्टला टाकलेला आहे, SUKला टाकलेला आहे आणि इंडिव्हिज्युअल माझ्याकडे जवळपास 140 ईमेल आयडी आहेत, तिथं पण आम्ही ईमेल पाठवलेला आहे.
बर सर, असो, काय हरकत नाही, आपण वाढवायला नको. एक फक्त मेसेज ह्या सगळ्यांना देऊया की सगळ्यांनी हजर राहायचे, कॉलेजचा प्रत्येक प्रतिनिधी, किमान एक प्रतिनिधी तरी पाहिजे.
हो,
बरोबर.
आता नेक्स्ट कॅरी ऑन करा सर, काम निमट सर.
चला पुढचा सेशन घ्या.
Thank you for very nice discussion. We will move to the next talk.
Thank you, sir. Thank you.
Second talk is by Dr. T.G. Shinde. I would like to introduce him in briefly because we are late. Dr. T.J. Shinde is presently working as associate professor at Srimati Kusumtai Rajaram Bapu Makanda Mahodalaya, Islampur. He has a teaching experience of more than 30 years and for UG and 4 years of teaching experience at PG. His research areas of interest are nanofarads, gas sensor, microwaves, and antennas. He has completed one research project funded by University Grants Commission. He has been awarded by Meritorious Teacher Award, which has been awarded by Rashtriya Bandhuta Sahitya Parishad and Bandhuta Pratishthan Pune in 2017. He has presented research papers in the international conferences held abroad at Singapore and China. He is a research guide in physics for Shivaji University, Kolhapur. 8 students are working under his able guidance. He has a good number of publications in reputed national and international journals. The total number of publications is 81. He is a Board of Studies member in physics. Presently, he is working as a Board of Studies member. He is also Board of Studies member at HM College, Karad, which is an autonomous college. He has worked as a resource person in many national and state level conferences organized in our university jurisdiction. He has been a committee member of the international conference organized at abroad. One of the important thing I would like to tell about him is that he has been awarded by outstanding reviewer for more than 8 journals. Some of I will mention here: Journal of Magnetism and Magnetic Materials, Journal of Allergy and Compounds, Material Science and Engineering B, and so on. Presently, he is working as a reviewer for more than 12 journals, 12 internal journals of the elsewhere. So, with this brief introduction, today we have with us Dr. T.G. Shinde, best teacher that we recognize him in our physics community. I request Dr. T.G. Shinde to deliver his talk on the second unit of this paper number 12. T.J. Shinde, sir.
Thank you. Thank you, sir. Thank you, Nimad sir. Thank you. Thank you, Nimad sir. Thank you. Very nice for nice introduction.
Proceed, sir.
But screen दिसते का बघा sir? Screen is it display screen?
नाही, share करा.
हा share मी केलेली आहे. First co-host.
शिंदे सर स्क्रीन दिसत नाही तुमची.
नाही तर co-host होता येत नाही इथून. एकच मिनिट.
त्यांना co-host करा की.
co-host करून घ्या त्यांना.
co-host करा आणि स्क्रीन त्यांना किंवा स्क्रीन शेअरचा ऑप्शन द्या. दोन्हीपैकी एक करा. पाटील मॅडम.
येस सर, ऍक्च्युली को-होस्ट केलेला आहे सरांना. मल्टिपल शेअर पार्टिसिपंट कॅन शेअर केलेला आहे सर.
मल्टिपल करू नका, त्यांना को-होस्ट करा.
नाही शेअर स्क्रीनला शेअर ऑप्शन हा येत नाही सर.
मोबाईलवर आहे का कशावर आहे?
मी याच्या मोबाईल वरतीच आहे सर. मोबाईल वरतीच आहे.
मोबाईल वर आहे तुम्ही.
मोबाईलवर क्लिक करा.
मोबाईल वरती आहे.
मोबाईलच्या सेंटरला क्लिक करा.
नाही मी
म्हणजे तो मार्ग दिसेल.
सर तुम्ही लेक्चर घ्या. हे माझं सेशन मी पुढे घेतो. ह्याला शिकवता ना, ह्याला शिकवायचं.
होते शिंदे सर.
थांबा जरा
सर, जरा परत करा. होईल. हा हो सर.
ऐकताय सगळे?
ऐकू येत आहे तर शेअर होत आहेत नाही काल शेअर होताना प्रॉब्लेम राहतोय काय तर.
शिंदे सर मग एक काम
बोला सर. बोला.
शिंदे सर एक काम करता येईल.
हा बोला सर.
तुम्ही पीपीटी पाठवा.
हा तुम्ही केलेदार सरांना ईमेल पाठवा.
पीपीटी पाठवा.
हा मग लगेच कॉम्प्युटर मधून शेअर करतील.
हा तिकडे पाठवा.
ओके सर. ओके.
शिंदे सर आता स्क्रीन शेअर होऊ शकते सर.
शेअर करतो सर, काय प्रॉब्लेम नाही सर. ओके. हॅलो, हा सर.
हा बोला सर, ऐकू येते.
हॅलो, काय की शेअरचा ऑप्शन आहे, जो स्क्रीन शेअर करायला ऑप्शन जो यायला पाहिजे होता तो येत नाही मॅडम.
सर मेल करता का सर तुमची पीपीटी?
ओके 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 ओके, लगेच मेल करतो मी.
अर्चना 96 ला करा सर.
नाही, मी व्हॉट्सअप हे ना करतो, किल्लेदार सरांना करतो व्हॉट्सअप वरती.
हो ओके, चालेल सर, चालेल.
ओके ओके.
टीजे शिंदे सर, मलाही पाठवा.
मी पाठवतो.
व्हॉट्सअपला पाठवा, व्हॉट्सअप.
ओके ओके.
हॅलो. हॅलो.
बोला.
सर
व्हॉट्सअपला
पण
पाठवले मॅडम.
तुमचं पाठवले का? ओके ओके.
हा, सरांच्या व्हॉट्सअप वरती पाठवले. हॅलो किल्लेदार सर पाठवलं बघा मग.
शिंदे सर लॅपटॉप जोडणं शक्य आहे का तुम्हाला? बघा तिथे. हॅलो
सरांचे कसं काय शिंदे सरांना कसं काही झालं?
त्यांचा प्रॉब्लेम आहे, त्यांच्या मोबाईलचा प्रॉब्लेम. आता आम्ही असं केलं.
हॅलो शिंदे सर.
हा सर शिंदे सर. हॅलो हॅलो शिंदे सर.
शिंदे सरांचा आवाज येत नाही.
शेअरिंग दिसून झाली ना? दिसलं?
हा शिंदे सर.
ओके झालं.
ते आहेत सर को होस्ट.
हॅलो हॅलो शिंदे सर. आर यू देअर?
आवाज येत नाही सर.
हॅलो थोरात सर. ओके. हॅलो वेळ जातोय खूप. आपण जरा पुढचं लेक्चर अगोदर घेऊयात. थोरात सर.
सगळे एकत्र लिहिले त्यांनी. तिन्ही पेन नाही दोन
थोरात सर.
तुमचं तुम्ही रेडी ठेवा. चालू आहे तुमचं.
आले शिंदे सर आले.
शिंदे सर आले.
आलोय पण सर शेअर स्क्रीन ऑप्शनच येत नाही याच्यावरती सर.
शिंदे सर मी इकडून शेअर करते स्क्रीन.
येतच नाही शेअर ऑप्शनच येत नाही. आता आला तुमचा ऑप्शन आला.
इकडून
शिंदे सर.
आम्ही शेअर केलेला आहे.
आला.
हॅलो
हा आता आला ऑप्शन आलाय.
सर नाही सर आता मी इकडून शेअर केले सर ऑलरेडी.
हा
तुम्ही तुमचं चालू करा लेक्चर. फक्त मला नेक्स्ट म्हणला तरी चालेल सर. मी करेन इकडून.
बर बर एकच मिनिट.
तुम्ही माने सरांना जे दिलेलं आहे ना ते वेगळं आहे. मग ते झेरॉक्स काढून घ्या.
शिंदे सर बोला तुम्ही. आम्ही इकडून नेक्स्ट म्हणा फक्त. आम्ही स्लाइड पुढे सरकवतो.
ओके 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 एकच मिनिट सर, एकच मिनिट फक्त, एकच मिनिट.
लॅपटॉपला चालू करून ठेवा सर. शिंदे सर लॅपटॉपला मग चालू करा, इकडे दिसते स्क्रीन. स्क्रीन दिसते ना आपल्याला.
घोडके सर, आता आम्ही इकडून पॉवर पॉईंट रन केलेलं आहे आमच्या इथून.
असं नाही की सर, ते काय करू देत, शिंदे सरांना फक्त लॅपटॉपला चालू करा म्हणा, इकडे आपल्याला दिसते स्क्रीन त्यांची, काय प्रॉब्लेम नाही.
त्यांच्याकडे लॅपटॉप नाही आहे.
हा ओके, मला स्क्रीन दिसू दे सर, चालू करतो मी. ओके 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 सर, ओके सर.
तुमच्या सर
सॉरी
लॅपटॉपला
सगळ्या
मोबाईलवरून बोला ना.
हा बोला.
मोबाईलवरून बोला तुम्ही.
मोबाईलवरून
तुम्हाला
बोलून
पाहिजे असेल तर
लॅपटॉपवरती
चालू
चालू
करून.
करतो.
हा मोबाईलवरती बोला की आम्हाला स्क्रीन
ओके
दिसते
थांबा
तुमची
थांबा,
सर.
मी लॅपटॉप पण चालू करतो. असं 2 मिनिटं घ्या सर. ओके ओके ओके, 2च मिनिटं सर, 2च मिनिटं. अमोल मोबाईल माझा ना, लॅपटॉप. हॅलो हा सर, स्क्रीन दिसते का हो सर?
दिसते बोला तुम्ही.
ओके
स्क्रीन दिसते तुमची सर, काय प्रॉब्लेम नाही. स्क्रीन दिसते तुमची.
हॅलो,
तुम्ही चालू करा सर, बोला.
आवाज येतो का सर?
हा आवाज येतो सर, तुम्ही चालू करा. इकडून मी पीपीटी शेअर
हॅलो.
केलेली आहे. हा शिंदे सर, हॅलो.
चालू करा म्हणून.
हा सर, तुम्ही चालू करा सर.
शिंदे सर, तुम्ही बोलायला सुरुवात करा.
हा सर, तुम्ही
काय झालं काय कळलं, काय तर ह्याच्यात प्रॉब्लेम लय मोठा झाला.
सरांना
नाही.
शिंदे सर, असं करूया का?
अर्चना,
हॅलो, ऐकू येते?
हा बोला की सर.
एक मिनिट, काय करा
हॅलो, आवाज
हो आणि थोरात सरांचं घेऊया का सर?
घ्या लगेच.
हो सर, हो. थोरात सर.
हॅलो, आवाज येतो, ऐकू मॅडम?
ऍक्च्युली थोरात, आय थिंक थोरात सर इज नॉट देअर.
आता थोरात सरांना मी बोललो की.
काय म्हटले थोरात सर? काय म्हटले?
घेतो म्हणून तुम्ही, थांबा, फोन केलाय मी.
नाही, टीजे शिंदे सरांना जॉईनला हे होईपर्यंत ते दुसरं आपण घेऊ शकतो ना.
तोपर्यंत थोडा सरांच सुरू करूया.
थोरात सरांचं घेऊया ना.
गोडके सर.
हा बोला.
हॅलो.
हा
बोला सर, बोला.
आले थोरात सर, तुमचं स्क्रीन शेअर करा आणि लेक्चर स्टार्ट करा.
थोरात सरांचं घेऊयात सर. शिंदे सर तुमचं नंतर घेऊयात आपण, ब्रेक नंतर.
व्हिडिओच कसं? हॅलो.
नाही, त्यांना ते काय झालंय.
येस जस्ट मिनिट सर.
नाही, शेअर स्क्रीन नाही आहे सर, इथे ऑप्शनच शेअर स्क्रीन वरती येत नाही.
सर, टीजे शिंदे सर
व्हाईट बोर्ड आहे
वेळाने घ्यायचं.
शिंदे सर,
हा बोला की.
तुम्ही थांबवा, आता मी चालू करतो.
बर.
नंतर
शिंदे सर तुमची स्क्रीन शेअर व्हायला लागली सर. जरा तुम्ही स्टॉप करा सर प्लीज.
हा.
म्हणजे थोरात सरांचं चालू होईल सर. हा, थोडस जमलिंग व्हायला लागले.
त्यांचं घोस्ट काढून टाका.
काय झालं काय?
आणि घे त्यांचं घोस्ट काढा ते.
ओके सर. थोरात सरांचं घेऊयात सर.
हा, पाहिजे का? पाण्याची बाटली भरली.
थोडा सरांचा
ओके. I would kindly request Dr. M.M. Tonpe sir to kindly chair the session and introduce about resource person of the third invited talk. Dr. M.M. Tonpe sir, Board of Studies, Associate Professor, KWC College, Sangli.
सर अनम्यूट करा, तुम्हाला ते सुरू करा. त्याचं इंट्रोडक्शन करू दे.
हॅलो हॅलो हॅलो
सर जस्ट मिनिट आहे, टोन पे सरांना का
मॅथ्स लावायची हे करायचं भेटत नसतं जेवण तर जेवण
दम लागला वर पळत जाऊन पळत. हॅलो पाटील मॅडम सुरू करू काय मी?
सर एकच मिनिट सर फक्त.
बर बर बर.
कमी करू सर.
किल्लेदार सर, थोरात सरांचं इंट्रोडक्शन करायचंय का? हॅलो
हो सर.
हा, ते माझे शिक्षक आहेत, हे एक इंट्रोडक्शन पुरेसं आहे.
आणि सुरू करा
सुरू करा सर तुम्ही.
सुरू करा.
हॅलो हॅलो ओके ओके. Good afternoon everybody and welcome to all in the second session of workshop.
बाकी म्यूट करा.
Am I audible?
Yes sir, you are audible sir.
Yes sir, you speak.
अर्चना बाकीच्यांना म्यूट करून टाका.
Yes sir.
Myself Dr. JB Thorat, Head Department of Physics, Sadhguru Gadge Maharaj College, Karad. Good afternoon everybody and welcome to all in second session of workshop on physics theory syllabus of paper 9 and 10, which prescribed by Shivaji University, Kolhapur for semester 5 of BSc 3 course and organized by RajarshiChhatrapatiShahuCoge, Kolhapur. I also heartily welcomes to Professor K.Y. Rajpure, chief guest of this workshop and Head Department of Physics as well as Chairman of BOS in Physics, Shivaji University, Kolhapur. I also welcomes to Dr. S.T. Salunke sir, Principal, RCSC College, Kolhapur, Dr. V.V. Killedar, HOD of Physics, RCSC College, Kolhapur. First of all, I would like to express my deep thanks to Dr. V.V. Killedar, organizer of this workshop, for giving me this opportunity to share this session as a resource person. Now I am going to deliver my presentation on the second unit of paper 9 of revised syllabus of semester 5. The first chapter from this unit 2 is some special integrals. In this some special integrals, it includes the article that is gamma function, properties of gamma function, beta function, properties of beta function, relation between beta and gamma functions, error functions. These articles are included in this chapter. Now, first see the introduction. In introduction, explain why beta and gamma functions are called special integrals. What is the role of these functions in physics? The gamma and beta functions appear frequently in physical problems such as normalization of wave functions and computation of probabilities in statistical mechanics. Their importance arises from their usefulness in developing other functions like hypergeometric, error, fractional, elliptical, and periodic functions, and in some integrals, etc., which have direct physical applications. Both functions are improper integrals and have very close relationship. Now see the first article, that is gamma function. In this first article, gamma function, we have to explain definition of gamma function. That is, the gamma function is denoted by gamma n, or read as gamma n. There are three definitions of gamma functions. The first one is the gamma function in terms of Euler's definite integral is defined as gamma n is equal to integration from 0 to infinity of x raised to n minus 1 e raised to x into dx for n greater than 0. The above integral is convergent. The second definition is the gamma function in terms of Euler's infinite limit is defined as gamma n is equal to limit m tends to infinity of 1 into 2 into 3 and so on m divided by n into n plus 1 into n plus 2 and so on into n plus m, bracket complete, into m raised to n, where n may be either real or complex number. Third definition is the gamma function in terms of Weierstrass's infinite product is defined as reciprocal of gamma n is equal to n e raised to gamma n production over m is equal to 1 of 1 plus n upon m into e raised to n upon m, where production over m is equal to 1 to infinity stands for continuous product and gamma is constant known as Euler's Mascheroni constant. Above all definitions are equivalent, so use any one, but first definition is more convenient and useful. The second article from this chapter is properties of gamma function. There are different properties of gamma function. Out of these properties, we can teach the students gamma n plus 1 is equal to n into gamma n. Here a mistake, n into n, but here n into gamma n. Second, that is gamma 1 is equal to 1. Third property is gamma n is equal to n plus 1 factorial. Fourth property, that is limit n tends to infinity of gamma n is equal to infinity. Gamma n is equal to infinity. Fifth property, that is gamma n is equal to 2 into integration from 0 to infinity e raised to minus x square into x raised to 2n minus 1 into dx. Fourth property, that is gamma n is equal to k raised to n into integration from 0 to infinity of e raised to minus kx into x raised to 2n minus 1 into dx. ह्या ज्या काही प्रॉपर्टी असतील तर ह्या प्रॉपर्टींचं प्रूफ आपल्याला त्या ठिकाणी विद्यार्थ्यांना शिकवायचं आहे आणि त्या प्रॉपर्टी सॉल्व्ह करून दाखवायच्या आहेत त्यांना. सेकंड आर्टिकल इज दॅट बीटा फंक्शन. द बीटा फंक्शन, first explain the definition of beta function, then beta function denoted by beta mn, and it is defined as a improper integral. Integration from 0 to 1 of x raised to m minus 1 into bracket 1 minus x raised to n minus 1 into dx, where m greater than 0, n greater than 0, means m and n are the positive numbers. Therefore, here beta mn is equal to, we can write integration from 0 to 1 of x raised to m minus 1 into 1 minus x raised to n minus 1 into dx. This is the definition of beta function. For m greater than 0 and n greater than 0, the above integrals are convergent. There are two variables, m and n, involved in the beta function. Another, that is properties of beta function. Here, first property, that is the beta function is symmetric. Means here we have to prove that beta mn is equal to beta of nm. This is the symmetric property. Second property is that beta mn is equal to 2 into integral 0 to 1 of sine raised to twice m minus 1 into x into cos raised to 2n minus 1 x into dx. Means here we have to prove this second property. In definition, to prove this second property, here put x is equal to sine square theta, dx is means dx is equal to 2 sine theta cos theta into d theta. When x is equal to 0, if we put these values in the definition of beta function, then the limits of beta function changes and becomes x is equal to 1 and theta is equal to pi by 2. If we make this substitution in the beta function or in the definition, and if we simplify, then we will get the proof of second identity or second property. Third, that is beta mn is equal to integration from 0 to infinity of x raised to m minus 1 divided by 1 minus x raised to m plus n into dx. This is modified form of beta function. In definition of beta function, to solve this property, in definition of beta function, put x is equal to y divided by 1 plus y. Then dx is equal to dy upon 1 plus y square, or y is equal to x upon 1 plus x. If we make this substitution in the definition of beta function, then limits of beta function, limits of integral changes. For x is equal to 0, limit becomes x is equal to 1. For y is equal to 0, y limit changes to infinity. And then if we simplify, then we will get the proof of this third property. Fourth property is that integration from 0 to 1 of sine raised to p of x into cos raised to q of x into dx is equal to 1 upon 2 beta of p plus 1 upon 2 comma q plus 1 upon 2. To solve this property, make substitution, that is twice m minus 1 is equal to p and twice n minus 1 is equal to q. Therefore, we will get m is equal to p plus 1 divided by 2 and n is equal to q plus 1 divided by 2, and put this substitution in property 2 and simplify, then we will get the proof of this fourth property. The third article from this chapter is relation between beta and gamma functions. The relation between beta and gamma function is given by the relation, that is beta mn is equal to product of gamma n and gamma n divided by gamma m plus n. This relation is given by like this. Then prove the gamma of gamma 1 upon 2 is equal to under root pi as an example. Another, that is prove that 2 raised to twice m minus 1 gamma m into gamma m plus half is equal to under root of pi into under root of twice gamma. Prove this formulas as a example or as a identities. Here, First article from the chapter is error function. In the error function of x is denoted by ERF of x, and it is defined as ERF of x is equal to 2 upon under root of pi into integration from 0 to x of e raised to minus t square into dt. This is the definition of error function. The function defined by the integral, that is 2 upon under root pi into integration from 0 to x of e raised to minus t square into dt, is called complementary. Instead of 0 to x, take 0 to infinity. E is called complementary error function and denoted by ERFC of x, and it is given by ERFC of x is equal to 2 upon under root pi integration from x to infinity e raised to minus t square into dt. Means in this error function, if we change the integral instead of 0 to x, that is x to infinity, then it is denoted as complementary error function or ERFC of x. This is about the error function. Now see the properties of error function, and we have to prove or teach the properties like ERF of x, error function of x is equal to 0, error function of infinity is equal to 1. The error function of x and their summation of error function of x and their complementary error function is equal to 1. Fourth property, that is error function of x is equal to minus error function of x. Error function of x is an odd function for all x. Another, that is complementary error function of minus x plus complementary error function of x is equal to 2. And the sixth property, that is nothing but the expansion of error function. All these properties we have to teach the students and show by proving it. This is about the first chapter from the second unit. The second chapter from the second unit is complex analysis. Number of lectures for this chapter is 12 hours. First, give the introduction about the complex numbers. Means define and explain the complex number. What is meant by real part of the complex number? What is meant by imaginary part of the complex number? What is the argument and modulus of complex number? What is the complex conjugate of complex number? All these things first explain in the introduction. Then we have the first article from the chapter is that revision of complex numbers and their graphical representation. We know that complex number is given by z is equal to a plus ib, where z is called as the complex number. I is nothing but the it's constant, and it is equal to imaginary constant, and it is equal to under root of minus 1. A is the real part and b is the imaginary part of the complex number. Explain Argand diagram with some examples. Next article, that is geometrical representation of complex number. In this article, explain the trigonometric or polar form of the complex number as well as exponential form of complex number. Means we can convert z is equal to a plus ib into the trigonometric form, that is cos theta plus I sin theta, or in exponential form, that is equal to, we can write r into e raised to I theta. Explain all these things in this article. Next article is nothing but the equality of complex numbers. Next article is that algebra of complex number. In algebra of complex number, we have to teach the students addition of two complex numbers and their geometrical representation. Means how to add the two complex number, how to geometrically represent the points on the graph. Then teach the students subtraction of two complex numbers and their geometrical representation. Similarly, third article in this complex numbers is multiplication of two complex numbers and their geometrical representation, as well as division of two complex numbers and their geometrical representation. Fifth, that is conjugate of complex number and their geometrical representation. Means here we have to teach the students addition, subtraction, multiplication, division and the
थोरात सर थोरात सर
बोला बोला
जरा एक शंका अशी होती.
हा बोला की
आपल्याकडे आर्टिकल आहे ग्राफिकल रिप्रेझेंटेशन आणि जॉमेट्रिकल रिप्रेझेंटेशन. अनेक रेफरन्स बुक बघितले तर दोन्ही एकसारखंच आहे.
होय 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 तसं
ते सिलेबस मध्ये असं वेगळं का घेतलंय जरा त्याच्याबद्दल चर्चा व्हावी म्हणून मी म्हणजे त्याच्याबद्दल कळावं ह्याच्यासाठीच तुम्हाला विचारलं. काय ना कारण का ग्राफिकल प्रेझेंटेशन
ग्राफिकल असंच रिप्रेझेंट केले किंवा काही ठिकाणी मिनिंग एकच आहे,
दोन्हीचा अर्थ एकच आहे. आर्टिकल मध्ये वेगळं आहे सिलेबस मध्ये.
हो पण आपल्या सिलेबस मध्ये आता ते तसं झालं, पण ते कन्सिडर करताना ग्राफिकल किंवा जॉमेट्रिकल असं घेतलं.
पण ते लोक विद्यार्थी विचारणार ना हे ग्राफिकल रिप्रेझेंटेशन शिकवलं नाही सर तुम्ही जॉमेट्रिकल शिकवताय, मग ते सिलेबस मध्ये ती लाईन तशीच घेतलेली आहे.
हॅलो कदम सर.
हा बोला.
हा अशी जी एरर आहे ही आता वर्कशॉप मधनं आपण कन्क्लूड करतोय. ऑल द टीचर्स आर अटेंडिंग दिस वर्कशॉप. टेक द काइंड नोट ऑफ दिस.
हा बरोबर आहे.
आणि म्हणूनच वर्कशॉप आहे हे लक्षात घ्या. तर सर्वांनी याची नोट घ्यायची आणि आपल्या विद्यार्थ्यांच्या पर्यंत सांगायचं आहे.
हा रेफरन्स नोट तुमच्या आला नाही मुद्दा हा, म्हणून मी हा मुद्दा काढला.
ठीक आहे.
2-3
हे तेवढं काहीतरी करेक्ट करा आणि पुढे चालू करा.
चालेल चालेल. ओके 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 थँक्यू सर. देन टाइप्स ऑफ कॉम्प्लेक्स नंबर्स. द टाइप्स ऑफ कॉम्प्लेक्स नंबर मध्ये आता हे थोडक्यात ओनली डेफिनेशन्स आणि त्याची एक्झाम्पल द्यायचे आहेत. रेग्युलर कॉम्प्लेक्स, व्हॉट इज मीन बाय रेग्युलर कॉम्प्लेक्स नंबर, झिरो कॉम्प्लेक्स नंबर, प्युअरली रिअल कॉम्प्लेक्स नंबर, प्युअरली इमॅजिनरी कॉम्प्लेक्स नंबर. यांच्या फक्त डेफिनेशन्स अशा आहेत.
आता आमच्या डोक्यावर घाला पोहेंच्या. त्याला काही वेळ असते की नाही विष्णू? 11 म्हणजे 11 आलं
नाही.
मी काय म्हणतोय जेवायच्या
नेक्स्ट आर्टिकल स्क्वेअर रूट ऑफ कॉम्प्लेक्स नंबर्स. तर याच्यामध्ये सुद्धा
आता आमचा जेवायला जातो नंतर
कॉम्प्लेक्स नंबरचा स्क्वेअर रूट कशा रीतीने घ्यायचा हे शिकवायचं आहे. अँड नेक्स्ट आर्टिकल इज लॉगॅरिथमिक फंक्शन ऑफ कॉम्प्लेक्स व्हेरिएबल्स. इन दिस आर्टिकल लेट C star be a set of non-zero complex number and C is set of all complex numbers. Then we define a logarithmic function of complex variables Z belongs to C star as a log Z. Therefore, Z is equal, now let Z is equal to R e raised to I theta as Z is non-zero. Then we can define the log Z is equal to log of mod of Z plus I argument of Z. Means logarithmic function of complex variable is defined by log of Z is equal to log of mod of Z plus I into argument of Z. And next article is Euler's formula. The Euler's formula is given by the relation e raised to I theta cos theta plus I sin theta. To solve this, consider the series expansion of e raised to x, cos of x, sin of x, and then replace x by I theta and simplify. Then we will get the proof of Euler's formula, that is e raised to I theta is equal to cos theta plus I sin theta. Then there will be a sum identities under Euler's formula, that is, and we have to teach the student these identities or give the proof of these identities. That is e raised to minus I theta is equal to cos theta minus I sin theta. Next identity, that is cos theta is equal to e raised to I theta plus e raised to minus I theta upon 2. Third, that is sin theta is equal to e raised to I theta minus e raised to minus I theta upon twice I. And fourth identity, that is z is equal to r raised to I theta, exponential form of complex number. These identities we have to teach the students. Next article, that is De Moivre's theorem. The De Moivre's theorem is defined as cos theta plus I sin theta raised to n is equal to cos n theta plus I sin n theta. For any rational values of n, the value or one of the value of cos theta plus I sin theta raised to n is cos n theta plus I sin n theta. And hence the De Moivre's theorem, that is cos theta plus I sin theta raised to n is equal to cos n theta plus I sin n theta. Under this, there are two identities, that is cos theta minus I sin theta raised to n is equal to cos n theta minus I sin n theta. And second, that is cos theta plus I sin theta raised to minus n is equal to cos n theta minus I sin theta. Means we can prove cos theta minus I sin theta raised to n is equal to cos theta plus I sin theta raised to minus n under the De Moivre's theorem. And last article from the chapter is Cauchy-Riemann conditions. The function f of z is equal to u of xy plus I v of xy is analytic or differentiable at point z is equal to x plus I y. If the first order partial derivatives of u and v exists and satisfies the condition da by u upon da by x is equal to da by v upon da by y, and da by u upon da by y is equal to da by v upon da by x, then u of x is equal to vy and ux is equal to vy and uy is equal to minus vx. These conditions are known as Cauchy-Riemann conditions for function to be analytic. Here first explain analytic function and then prove the theorem. Now see the reference books for this unit 2, that is mathematical physics, B.S. Rajput, mathematical physics, H.K. Das, and Ram Verma, mathematical physics by P.K. Patil and J.K. Nandgave. 4, that is complex analysis by P. Durain Pandian and K. Pachiappa, and mathematics for physics by S.M. Lee, published in 2004. Thank you very much. If you have any doubt, please ask.
थोरात सर.
हाँ ओके.
हाँ, Cauchy-Riemann कंडिशन.
हाँ.
तर या कंडिशन घेत असताना आतापर्यंत तुम्ही कॉम्प्लेक्स नंबर विषयी बोललाय.
होय.
पण कॉम्प्लेक्स फंक्शन कुठे डिफाइन केलेलं नाही.
कॉम्प्लेक्स
व्हॉट इज मीन बाय कॉम्प्लेक्स फंक्शन कॉम्प्लेक्स फंक्शन घेतल्यानंतरच Cauchy-Riemann कंडिशन सांगता येते.
ओके सर.
ह्या आर्टिकलच्या पूर्वी फक्त आपण कॉम्प्लेक्स नंबर एवढेच पाहिलेले.
होय.
मग आपल्याला इथं कॉम्प्लेक्स फंक्शन म्हणजे काय हे सांगावं लागेल.
आपल्याला इंट्रोडक्शन मध्ये आता याच्या सांगत असताना आपल्याला ते कॉम्प्लेक्स अनालिटिक फंक्शन किंवा कॉम्प्लेक्स फंक्शन सांगावं लागेल. ते फंक्शन असं आहे, a function f of z is said to be analytic at a point z is equal to z.
नाही. हो, थोरात सर, तुम्ही सांगताय ते बरोबर आहे. माझं म्हणणं असं आहे की पूर्ण चॅप्टर मध्ये तुम्ही कॉम्प्लेक्स नंबर विषयी बोलता, पूर्ण चॅप्टर मध्ये.
होय.
आणि या कंडिशन मध्ये कॉम्प्लेक्स फंक्शन हा शब्द वापरतो आपण. कॉम्प्लेक्स फंक्शन वापरतो शब्द आपण, कॉम्प्लेक्स नंबर वापरत नाही. आणि पूर्ण चॅप्टर मध्ये कॉम्प्लेक्स नंबर आपण शिकतो. तर कॉम्प्लेक्स फंक्शन म्हणजे काय हे अगोदर सांगावं लागेल
मुलांना, आणि त्याच्यानंतर
आणि कॉम्प्लेक्स फंक्शन सांगितल्यानंतर कॉम्प्लेक्स फंक्शन अनालिटिकल कसं आहे त्याची काय डेफिनेशन ते सांगावं लागेल.
हो हो,
हे असं माझं मत आहे.
आणि त्याच्यानंतर थेरमचं प्रूफ द्यावं
मग ती कंडिशन तुमची तुम्ही डिराईव्ह करता हो. ही मुळे आपण एमएससी ला शिकलेलो होतो आपण. पण आता कसं आहे, हे पूर्ण सिलेबस सेट करताना कॉम्प्लेक्स फंक्शन असा कुठेही शब्द नाही. आणि कॉम्प्लेक्स फंक्शन शब्द नसताना ही कंडिशन घातलेली आहे.
कंडिशन डायरेक्ट आहे.
हा, ही कंडिशन काय कॉम्प्लेक्स नंबरला नाहीये, ही कॉम्प्लेक्स फंक्शनला कंडिशन आहे.
फंक्शनला बरोबर आहे.
मग ही करेक्शन करा, नाही मला काय सांगायचं फक्त ही करेक्शन करा तुम्ही पुन्हा सिलेबस मध्ये नंतर पुढे.
ओके ओके ओके,
एवढंच म्हणणं आहे, बाकी काय नाही. करेक्शन व्हावी पुढे.
थँक्यू सर. आता ह्या युनिट मध्ये जर पाहिलं तर बीटा गॅमा फंक्शन मला वाटतं आपण जुन्या सिलेबस मध्ये ते SY BSc ला मॅथमॅटिक्स मध्ये बीटा गॅमा फंक्शन आपण शिकलेलं आहे. त्याचबरोबर हे फंक्शन जे आहेत किंवा कॉम्प्लेक्स नंबर्स आहे, ते कॉम्प्लेक्स नंबर सुद्धा आपण कॉम्प्लेक्स व्हेरिएबल्स किंवा कॉम्प्लेक्स अनालिसिस हे मॅथमॅटिक्स मध्ये SY BSc ला जवळपास झालेलं आहे. ते आता पुन्हा आपल्याकडे सिलेबस मध्ये आले. त्यामुळे ह्या बऱ्यापैकी झालेला सिलेबस असेल. आणि इतर काय कोणाच्या क्युरीज असतील तर विचारायत.
काय काय करताय ते दिसत.
हा नमस्ते सर, बोला की. हा आहे जॉईन झालोय सर.
हा हे बघा, पार्टिसिपेंटला माझी एक सूचना आहे.
हा,
आता हे सगळे सेशन झाल्यानंतर तुम्हाला या सिलेबस संदर्भात वाटत असेल घेऊन ठेवा. प्रत्येकाला नंतर एक BOA चेअरमनला पत्र पाठवा. तुम्हाला जे काय म्हणायचं असेल ते पत्र तुम्ही BOA चेअरमन कडे पाठवा. त्यानंतर एक कमिटी आम्ही करत असतो. तुमची सूचना जर योग्य असेल त्या अमेंडमेंट ज्या आहेत आम्ही पुढच्या वर्षी करत असतो. तुम्ही सुरुवातीला माझ्या प्रास्ताविक मध्ये सूचना एक केलेली होती. आजचं जे सेशन आहे ते सिरियसली ऐका. माझ्या काही सुधारणा कराव्यात असं वाटत असेल त्या सगळ्या तुम्ही BOS ला कळवा.
लिहून घेतलेला आहे सर आताच्या तरी.
कार्यवाही करेल. ओके.
Thank you, sir. Now it's time to approach lunch. We all will gather here on the same platform after 30-minute break. Please have a lunch and do come back to the same platform. We will gather here at sharp 2 p.m. So enjoy your lunch.
सर्वांनी अर्ध्या तासानंतर परत जॉईन व्हायचं आहे. आता आपण लंच ब्रेक करतोय, लक्षात घ्या. अर्ध्या तासानंतर सर्वांनी परत जॉईन करा. त्याच्यानंतर आपण युनिट 1 बघणार आहोत मॅथमॅटिकल फिजिक्स मधलं, आणि त्याच्यानंतर मग इलेक्ट्रॉनिक्सचं युनिट.
हो तयार आहे सर, मी किल्लेदार सर तयार आहे.
बोला.
सूचना असेल सरळ टायमिंग 2चं द्या की 2ला स्टार्ट करूया.
2 वाजता आपण स्टार्ट करतोय.
करेक्ट चालेल.
चालतं. ओके
ओके, थँक्यू.
लंच ब्रेकची स्लाइड पाठवायची.
चालूच राहणार सर. चालूच राहणार. अर्चना काय करा बघा, इथं कुलूप आहे बघा.
काय होते रे काय बंदी करून कुठे गेला कुठे काय तुला आपलं नमस्कार केलं कुठं हे जाऊ दे बाकीचं म्हणा बघून चालू करू जेवायला जेवाय दे काय चुकीचं माहिती तू 12 वाजता इथं आलेला मला म्हटलंय तर मला म्हणा आता येऊन गेलो मी हे एवढी पापडी देते गाडगे सरांना देऊन आले ती होय गाडी श्री होय पण पण सकाळी उठतो पुरी भाजी खाली पुरी भाजी कुठे शिक मध्ये बरं ते विषय ना विषय ते धंदा होता ते बरं का विचार थोडी शकतो आपण कुणाच आहे बघा किती येत आपण कुठपर्यंत मी कसं पाण्याच्या ठिकाणी जांभा झाड पाहिजे मस्त जांभा झाड पेरू आंबा आणि कुठलं जांभळाचे पाणी घेऊन कुठलं काय घेताय का दारू सोडू आणि मी तुम्हाला लिहून देतो मी बघतोय तुम्ही सोडू शकणार नाही दारू थांबा ना कसं आहे माहिती का पाटील व्यसन म्हणजे दारू ही अंजा म्हणून प्यायची पहिले येऊन खवळून पिते हे पुन्हा मिळते का नाही की असं काय करते झालं ना सोडू नका पण ते लिमिटेशन काय आमचं कसं नाही तर नाही नाही तर असं तरी करायचं स्वतःच मन कंट्रोल मध्ये करायचं तिसरा पेग झाला आजपासून तिसरा पेग झाला की बंद ठीक आहे तिसरा त्याच्यात तुमचं कसं आहे तुम्ही नंतर जास्त हाय पॅक घेतात हेवी अगोदर लहान पॅक घेतात आणि नंतर हेवी पॅक घेतात हा डेंजर असतं चेहऱ्यावर जाणवत माझ्या लगेच पण तुम्हाला सगळं बघितलेलं सांगितलं तुमचं हल्ले काय.
हो सर, नवीन सिलेबस आहे तुमच्याकडे टीवायचा नवीन सिलेबस आता नाहीये. हा
Welcome to all the participants for this post-lunch session. I would kindly request Dr. M. Tonpe sir to kindly chair the session and introduce about resource person of this invited talk.
Thanks, madam. After lunch section, good afternoon, one and all my friends and colleagues. I am Dr. M. Tonpe, Head Department of Physics, Srimati Kasturba Walton College, Sangle. First, I thanks Dr. S.T. Salunkhe sir, Principal, RajarshiChhatrapatiShahuCoge, Kolhapur, convener of this workshop, and my friend Dr. V.V. Killedar sir, all organizing committee members of new changed BSc3 CBS curriculum of physics for giving opportunity as a chairperson for today's workshop. I also thankful to our Pro-VC, Professor P.S. Patil sir and Professor K.Y. Rajpure sir, Head Department of Physics and Chairman of BOS in Physics, Shivaji University, Kolhapur, giving full support and help for preparing and changing the BSc3 CBCS syllabus. After lunch, today's resource person is Dr. UK Mohite sir. Mohite sir is working as an associate professor and head department of physics at Matosri Bayabai Sripatrao Kadam Kanya Mahavidyalay, Kadegaon, district Sangli. Sir has 30 years teaching experience and 4 years PG at PG level. Sir completed his UG, PG and PhD from Shivaji University, Kolhapur. Has published near about 15 papers in international and national publications. He attended 46 conference, seminars, workshops at national, international, university levels. Sir is a member of Board of Studies in Physics in 2006 to 2011. Now, he is also a member of Studies of Board in Physics at Kolhapur. He is also the member of 32/5G Committee for Physics, Shivaji University, Kolhapur. Sir awarded APJ Abdul Kalam National Award for Teaching by International Institute of Social and Economic in 2019. Now, I request to Mohite sir to deliver his talk towards the Mohite sir.
Thanks. And I am going to start. I am audible?
Yes, sir.
Yes, sir.
Thanks to Principal S.T. Salunke sir, the Principal of RajarshiChhatrapati Shahu College, Kolhapur, Professor K.Y. Rajpure sir, Chairman of Board of Studies Physics, my colleague, my friend, Dr. V.V. Killedar sir, member of BOS and working as a head in Chhatrapati Shahu College, Kolhapur, and all organizers, those who are arranged this workshop for the newly changed syllabus for the BSc part first. So I'm very thankful for the organizers to give me the opportunity to share my views regarding this paper number 9, having 36 lectures, 25 lectures of 48 minutes, which is named as DSc E1 as a mathematical physics, which is included in semester 5. So, in this paper, already 2 chapters in the unit 2nd was discussed by the Professor Thorat from HM College, Karad. And I want to explain this particular unit first, having the 2 topics. First one is the partial differential equation, and second one is the Frobenius method and special functions. So this is the syllabi given by the university, or which is designed already by the BOS of Shivaji University, Kolhapur. With this, we are going to discuss the following sub-articles from the differential equation, that is the introduction to differential equation. In that we must discuss what are the types of the differential equation. Then it is necessary to discuss the basic things for the differential equation, that are the order and degree of differential equation, examples to find the order and degree of differential equation, what is the homogeneous and linear differential equation, then examples to decide homogeneity and linearity of the differential equation. In short, it is this introductory part.
सर थोडंसं स्क्रीन लहान करा, झूम कमी करा जरा, झूम लेवल कमी करा थोडंसं.
1 minute. ओके,
थोडंसं हळूहळू वाढवता येईल का बघा, थोडंसं बरोबर सेंटर ऍडजस्ट करा. कट होतंय थोडंसं उजव्या बाजूचं. हा हा हा, ओके, बस ठीक आहे.
So in second article in that differential equation, that is the solution of second order partial differential equation. In that method of separation of variables of solving second order differential equation, application to second order partial differential equation, two-dimensional Laplace equation in Cartesian coordinates, solution of two-dimensional Laplace equation by method of separation of variables, solution of three-dimensional differential equation, that is Helmholtz equation in Cartesian coordinate system, then introduction to progressive wave, types of progressive wave, differential equation, that is the derivative of progressive wave, and lastly the solution of the progressive wave by the method of separation of variables. So these are the sub-articles which are taken in the introductory part of the, that is the first chapter of that, that is the differential equation. In second topic, that is Frobenius method and special functions, we should cover all these points. Basically, that is what is the singular points of second differential equation, definition of ordinary and singular points, that is ordinary and singular points, regular and irregular singularity, singularity at finite non-zero point, singularity at point at infinity, then application of singularity to Legendre and Bessel differential equation. So this is a very important article which is included in syllabus. In that we cover form of Legendre differential equation, application of singularity to Legendre differential equation, then what is the form of Bessel differential equation, and then to find the singular point of Bessel differential equation. Then we discuss the Frobenius method, that is the power series method, to solve the second order differential equation. In that we inculcate these articles, that is series solution method of solving second order linear differential equation, examples on series solution method to solve the second order linear differential equation, and lastly application of Frobenius method to solve the Legendre differential equation. So all these points we should cover. So one by one we take these two topics in details so that we should understand that is the what is the weightage corresponding to each and every sub-article. So this is the actual syllabus which is given by the university in first para. In introductory part, we should discuss about the second order differential equation. Then what is the ordinary, in the types of the differential equation, we discuss the ordinary differential equation, their example. Then we discuss the partial differential equation, this definition, some examples. Then we go towards order of differential equation, and we finish this order with some examples in order to how to calculate the order. Then goes towards the degree of differential equation. So we can't read what is the definition of the order and degree of differential equation. We should know all that definition. I here only discuss what things we should be cover in the classroom for the students. So this is the degree of differential equation, and this is some examples corresponding to degree of differential equation. Then we goes toward the linearity of differential equation. In that linearity, we give first definition of the linearity and what are the conditions for the linearity. So these are the three conditions for the linearity of the differential equation. So by defining these three conditions, this is the general linear differential equation. You should discuss the form of that general linear differential equation which satisfies all these three conditions. Then we discuss the linearity for some basic examples. So these are some examples, and with that definition and these three conditions, we categorize these given equation in linear and non-linear form. So with the examples, we should discuss the linearity. Then we go towards the homogeneity of the differential equation. Actually, linearity, homogeneity, order, degree, all that things are not mentioned in the syllabus. But in syllabus, we have the introduction to differential equation. In next articles, we should know for the that is the in Frobenius method, yeah, power series method. We should know all these basic things for the differential equation. So we should cover all these things. So this is the homogeneity of the differential equation. So this is the general differential equation. In that general differential equation, this is the rough method is given here in order to discuss the homogeneity, that is what are the powers corresponding to each and every term in this general differential equation for the m and n in this equation, because m into dx into n into dy, that is equal to 0. This is the simple differential equation in which we have this is the m and this is the n. If the form of m and n is like this, so with this power of the variables is same here, at that time we say that that is the homogeneous differential equation. Then there is the second definition, yeah, second method to decide the homogeneity of the differential equation by write the differential equation in the form of this dy by dx, that is equal to fx, or we should convert that equation in the form of the variables x divided by y, f of x divided by n, f of y divided by x. Then separately we can easily decide the homogeneity of the differential equation. Then what is the form of two-dimensional Laplace differential equation? Here we should know, instead of solving this Laplace differential equation, before that we should know this is the form of two-dimensional Laplace differential equation. So this is the simple form of the two-dimensional Laplace differential equation, and then we goes toward the solution of this differential equation by method of separation of variables. So this is the general equation, homogeneous equation. We should write that is d2y by dx square plus d2u by dy square, that is equal to 0, where u is the function of f of x and RHS is 0, so that it is a homogeneous. So we assume the solution of this equation as u into x into y. By assuming this equation, we write the value of u in equation number 1, and we have this equation by partially. If we think about this second order differential equation, in first term y is independent, yeah, y is constant with respect to this d2y by dx square, and here x is constant with respect to d2xy by dy square. So that we should take the simple form by constant terms outside the differential parameter, then dividing the whole equation by xy, and finally we got these two things, that is separate terms of the x in this part, and here we have separate terms of the y in this part, and we write that is equal to lambda, where lambda is the constant, that is the separation constant. From that we write these two separate equations from given differential equation. Now, 1 minute. By defining the d operator, we are going to solve these two equations as a such d, that is equal to dou2 by dou x, and d square, that is equal to dou2 by dx square. We are going to write the homogeneous equation, quadratic equation in d for that two equation as 7 and equation 6 and 7, and by usual method we are going to solve the two simple second order differential equations with constant coefficient. The solutions are like this. So similarly we consider the second equation in terms of y, defining the d operator. Here we have again got the quadratic equation. With that quadratic equation we have the part of that solution is like this. So one solution in the form of x and another solution is form of the y. Final solution is equal to u into xy. So this is the solution of our equation, that is second order Laplace differential equation. Now we goes towards the two-dimensional Laplace differential equation. This is the form of the two-dimensional Laplace equation. It is obtained by the Coulomb's and Gauss laws by defining that D, defining the susceptibility, electrical intensity, volume of the charge density. In that, we got this particular equation, that is d2 phi equal to minus E phi by epsilon, and this is our Poisson's equation. And this Poisson's equation, if you write this is equal to 0, we got that is the Laplace equation in Cartesian coordinate system, which is a two-dimensional. So this is the two-dimensional Laplace equation. Now we are going to discuss regarding the solution of this two-dimensional Laplace equation. So two-dimensional Laplace equation is again solved by the above method. Simple thing. Assuming the solution phi that is equal to x into y, writing that assumed solution in equation number 1, then we are going to divide both equations by xy. Then we obtain these two separate equations in terms of x and y. By defining d operator, we got the quadratic equations, and by solving that quadratic equation by usual method, we write the equation for x and we write the equation, that is solution for the x and solution for the y, and finally we write the solution phi that is equal to x into y. So all these things we should know actually in the previous syllabus in the BSc part first, not BSc part first, in back syllabi. So you should discuss all that things, how to solve that first order and that is the second order Laplace equation and second order Laplace equation of the three-dimensional type. Now then we goes towards the solution of three-dimensional Laplace, three-dimensional partial differential equation in Cartesian coordinate system. So this is the form of the three-dimensional partial differential equation. d2 psi plus k square psi that is equal to 0. Again, the method is same, but small bit changes are there. Instead of obtaining two equations, here we got some multiple equations in order to the final value of the psi. So initially we assume the solution of the given differential equation as psi that is equal to phi xyz, which is the function of xyz, which is the Helmholtz equation. Then that solution is equal to phi 1 into phi 2 into phi 3, where phi 1 is function of x, phi 2 is function of y, and phi 3 is function of z. Then we write that solution in equation number 1. Then dividing throughout equation by phi 1, phi 2, phi 3, and we have, this is the one equation. Now with this equation, for this psi 1 we have this part, and this is equal to minus k1 square. Negative sign taken for our convenience. Similarly, that is from this equation we got, this is the first equation. Now from this equation we are going to obtain the second equation by taking another constant, that is the k2 square. And similarly, this is the second equation for this psi 2, and third equation similarly we obtain in terms of k3 square for the psi 3. And solving all these three equations by usual methods, already we discussed that methods, and writing final solution is equal to psi 1 into psi 2 into psi 3. Here it is not necessary to again writing the method of solving the equation for the psi 1, for psi 2 and psi 3 directly, because already all that things are covered in the above articles. Now then we goes towards the progressive wave. This is the article which is inserted in the syllabi. So we must know what is the progressive wave, what are the types of the progressive wave. So transverse waves and longitudinal waves are there. Then what are the equations, trigonometric equations in terms of x and t for the progressive wave. This is equation in terms of x and t, and that is y that is equal to a sine omega t minus kx, and here y that is equal to a sine kx minus omega t. That is, we are going to change the phase of that equation. That is, for opposite phase we got such type of the sign, but equation is same almost for that progressive wave. So from that progressive wave, we are going to define, this is the differential equation. We are going to derive the differential equation for that progressive wave by taking the initial y that is equal to a sine kx minus omega t. So differentiating with respect to t, then we are going to differentiate with respect to x, and again we take the double differentiation with respect to t, and finally we write this is the form of the differential equation, and which is the equation for the progressive wave in terms of x and t. So d2y by dt square, that is equal to k square into d2y by dx square. This is the progressive wave of the differential equation. And finally we cover what is the solution of the progressive wave, and that particular method is already discussed above. Again, this is our known equation. We write in standard format. We write the solution in terms of x and t. Then we must know what is the equation for the x and what is the differential equation for the t, so that we use the same method, that is by inserting the solution in this equation. Then by knowing the constant term, partial differential terms, that is t is constant with respect to x, and here x is constant with respect to t, so that we can take the outside that term, dividing throughout that equation by xt, and we generate finally two equations in terms of x and in terms of the t here. And by usual method, we are going to solve that equations in terms of x and equation in terms of y. In equation in terms of t. So this is the method of the solving solution for the progressive wave, and this is the final solution. Now we are going to discuss the second topic, that is the Frobenius method. Here we have the syllabus in first para. Limited articles are there looking in the syllabus, but actually we are going to bifurcate so many sub-articles in order to understand total Frobenius method and the special function. So for that purpose, we should discuss the what is meant by ordinary points and singular points for the given second order homogeneous differential equation. So for that purpose, we are going to convert the given differential equation in the standard format, so that we got the values of px and qx. And so from that values of px and qx, we have the condition for the ordinary function, that is both are found to be finite at x that is equal to x0. That means if you take the limit x tends to 0 for the p of x and limit for x tends to x0 for the qx, and if both are finite values, then we call that equations are ordinary. So if equation is ordinary, there is no question of the singularity. Then we discuss about the singular points of the differential equation. And for the singular point, these are the two conditions. That means P or Q must be equal to 0 at x tends to 0. This or this, or, and another condition is both are found to be infinite. म्हणजे P किंवा Q हा जर तुम्हाला x that is equal to x0 ला जर इन्फायनिटी मिळाला किंवा दोन्ही इन्फायनिटी मिळाली, तर त्या इक्वेशनला तुम्ही ऑर्डिनरी इक्वेशन म्हणणार नाही, त्याला आपण that equation has some singular points, so that equation have two singularities, that is not two, that is regular or irregular singularity. So for regular singularity the condition is different, and for irregular singularity that condition is different. That particular singularity is defined with this particular simple chart. That means we are going to take again the limit for the x minus x0 as x tends to 0 for px and x minus x0 bracket square into qx. And if that both values are finite, the point is singular, regular. And if one of the value is infinite, it is irregular. Both are infinite, it is irregular. And both are infinite. So sorry, first is infinite and second one is finite, that is irregular. And both are infinite, that is irregular. So from values of p and qx, we are going to decide or we are going to calculate the value of x minus x0 into px and x minus x0 bracket square into qx, and we decide that particular point is regular, yeah, irregular. So that thing can be explained. We should or you should explain by taking some example. Here I taken one example. In that example, directly we write in the standard form by dividing this equation by x square, so that we got the value for p of x and q of x. Then we obtain the values and we take the limits, yeah, x minus x0 px, and it is found that that particular values are finite. One value is finite and second value is again finite, so that it is a regular singular point. For irregular singular points, that again we have this particular condition as we mentioned already in above article. So for that purpose, again we take the limits corresponding to that p of x and q of x, and limits corresponding to x minus x0 px and x minus x0 bracket square into qx. We should decide the irregular singular points. So for that purpose, again you should take some examples. Here I take one example like this. So for that, this is the p of x, q of x, and it is found that this particular value is equal to infinity. So one of the values infinity, that particular point is found to be irregular singularity. So we can't proceed to find the limit corresponding to x minus x0 bracket square into qx here. Then we goes to the application of singularity to Legendre differential equation. Actually, we discussed this singularity for 3 points, that is 0 point, finite point, and infinite point. For x that is equal to x0, here we have the form of Legendre differential equation. We write that again in standard form by dividing this 1 minus x square. Comparing with this, we write the value for p of x and q of x. Then we decide the type of this equation, ordinary or other, so that we are going to find the limit for the px and limit for the qx. Both are here finite. So p of x and qx are not diverges at x that is equal to 0. Therefore, x that is equal to 0 is not a singular point for a Legendre differential equation. That is very important. Now we should discuss the singularity at a finite non-zero point for x that is equal to 0. Method is same. That is by writing that equation in the standard format, obtain the value of p of x and q of x, and taking the limit instead of x tends to 0. Here we take the limit as x tends to 1 here. The value is found to be equal to infinity, so that here p of x and qx are diverges at x equal to 0 is the point of singularity of given Legendre differential equation. Then we are going to decide the type of singularity. Then we are going to take the limit, same limit, that is x minus x0 p of x and x minus x0 bracket square q of x, and we are going to find the limit values. Here both values are finite, so that x that is equal to 1 is the point of a regular singularity. Now we finally goes towards the singularity at a finite non-zero point for x that is equal to -1. Same thing is there. 1 minute. Here we have the Legendre differential equation again. This is we write in our standard format. Then we write the value for p of x, q of x. Then we decide the point of regular or irregular, that is the singularity or ordinary differential equation. And then we are going to discuss the type of singularity, and it is found that x that is equal to plus or minus 1, both are regular singular point for given legendary differential equation. Now lastly we discuss the singularity at point infinity. Same method, instead of taking the limit as x that is equal to x tends to 0 or finite, we here take x tends to infinity for the legendary differential equation. Same values of p of x, q of x. Then we take the limits for x tends to infinity, and then we finally discuss about the we call it as a type of the singularity, and it is a simple thing. Both are found to be finite at z that is equal to 0 means x that is equal to infinity. So it is a regular singular point for the given legendary differential equation. Then lastly we discuss the application of singularity to Bessel differential equation. This is the form of the Bessel differential equation. Again we write the Bessel differential equation in terms of the standard form. Then we write the values of p of x and q of x. Then we use the usual method for the for decide the singularity. So we take the limit for x that is equal to here 0, and it is find that both are found to be finite. Hence x that is equal to 0 is a singular point for Bessel differential equation. Then to decide the type of the singularity, it is not necessary to decide the type of singularity, or it is found that both x that is equal to 0 is a regular singular point for given differential equation. This is the note, very important here. Then we discuss the Frobenius method, that is the power series method for the second order differential equation. Simple. We are going to write the second order differential equation. We assume the solution in the form of this series form, that is y that is equal to c0 plus c1 into x minus x0 plus c2 x minus x0 bracket square plus dash dash dash. Now differentiating equation 1, that is we obtain the value for dy by dx, d2y by dx square, and we substitute all these values in the given differential equation, and we obtain the equation in the form of k0, k1 and k2. Here we found the k0, k1, k2 that is equal to 0, and and from this equation we can obtain the values of c0, c1 and c2, and we write the solution of given differential equation. Find the to understand the Frobenius method clearly, we take the examples. So I taken here one example. I assume this is the solution of this example. Then I obtain this y dash and y double dash, that means taking the differentiation of this y and y dash again and putting these values in this equation, and we use the same method and writing this particular equation. Actually here for m that is equal to 1, we got the two values for k, and for both values of k we write the recurrence relation for the given differential equation, and from that recurrence relation for k that is equal to 0, what are the values of the a, and for k that is equal to 1, what are the values of the a, that is a1, a2, a3, yeah, a1, a3, a5 like that, or a2, a4, a6 like that, and all that values are putting in given equation. For k that is equal to 1, we have, this is the recurrence relation. In that recurrence relation we are going to insert the values for k that is equal to 1, and we obtain the values as a1, a3, a5 like that, and so that we got the values for that constant a2, a4, a6, a2r, and we write the solution like this. Similarly, we write the final equation as y that is equal to, by inserting the values of that a2, a4, a6 in this equation. That is the final solution in terms of power series. Now, solution of legendary differential equation by series solution method. So again, this is the standard form of the legendary differential equation. Then we assume the solution of that legendary differential equation in terms of this power series, take the differentiation equation, again obtain the respective equation by applying the condition of the recurrence relation, and with that obtain the values of A1, A2, A3, yeah, A1, A3, A5 or A2, A4, A6, A2R by knowing the respective values of the constant, and finally insert that values in the given assumed solution, and we got the particular solution of given legendary as y that is equal to A0 into A1 plus A1 into A1. So already we have obtained the values for A0 and A1 in above equation. So this is the solution of legendary differential equation. So if you have some doubts, if you have some queries, please send that queries on our WhatsApp group. I will clarify all that things. Thank you very much.
Jhatrapati sir. हॅलो, लिजेंडरी ऍप्लिकेशन पाहिलं बरोबर आहे. तिथं सिंग्युलर पॉइंट काय घेतलेला होता? हॅलो,
हा बोला ना सर.
लिजेंडरी डिफरन्शियल इक्वेशनला ऍप्लिकेशन घेतलं तुम्ही फॉरबिनेस मेथडचं, बरोबर आहे का?
1 मिनिट. मी स्क्रीनवर दाखव फॉरबिनेस मेथड.
फॉरबिनेस मेथड लिजेंडरी डिफरन्शियल इक्वेशन ऍप्लिकेशन आहे ते, त्याचं तुम्ही फॉरबिनेस मेथडनी सोल्युशन काढलं. ऍट व्हॉट सिंग्युलर पॉइंट? सिंग्युलर पॉइंट कुठला होता तिथं?
1 मिनिट.
सिंग्युलर पॉइंट किती आहे तिथं? x इज इक्वल टू 0 आहे, x इज इक्वल टू +1 आहे, x इज इक्वल टू -1 आहे.
स्क्रीनवर दिसतंय ते.
हा नाही, मला काय म्हणायचंय, लिजेंडरी डिफरन्शियल इक्वेशनला x इज इक्वल टू 0 इज नॉट सिंग्युलर पॉइंट, इट इज ऑर्डिनरी पॉइंट.
Yes.
बरोबर.
x इज इक्वल टू +1 -1 आर दी सिंग्युलर पॉइंट्स.
Yes.
मग तुम्ही ते सोल्युशन घेत असताना लिजेंडरी डिफरन्शियल इक्वेशनचं ती जी किंमत घेतलेली आहे सिंग्युलर पॉइंटची, ती फायनाईट घेतलेली आहे. फायनाईट घेतल्यानंतर त्या इक्वेशन मध्ये सोल्युशन मध्ये मॉडिफिकेशन करावं लागेल, असं आहे का? कारण x इज इक्वल टू 0 ला ते सोल्युशन वाटतंय. बघा मी काय म्हणतोय, तुमच्या लक्षात येतंय का?
इथं स्क्रीनवर तुम्हाला दिसतंय बघा, हेच ना, हे सोल्युशन मी पकडलं y दॅट इज इक्वल टू समेशन ऑफ n, बरोबर?
हा,
हेच ना.
हा नाही, माझा प्रश्न काय इकडे पहा की सर, लिजेंडरी डिफरन्शियल इक्वेशनला x इज इक्वल टू 0 हा सिंग्युलर पॉइंट नाही.
बरोबर 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 सर.
x इज इक्वल टू +1 -1 हा सिंग्युलर पॉइंट आहे.
अगदी बरोबर.
मग त्या पॉइंटला फॉरबिनेस मेथड अप्लाय होणार ना. फॉरबिनेस मेथड इज अप्लाइड फॉर सिंग्युलर पॉइंट्स.
ऍक्च्युली पॉवर तुम्ही म्हणताय ना पण सर, हे तिथं आपण जे एक्सप्लेन केलेलं आहे ते टाइप्स ऑफ सिंग्युलॅरिटी आणि म्हणजे कोणकोणत्या पॉइंटला तो म्हणजे सिंग्युलर पॉइंट आहे, आणि इथं पण एक्सप्लेन केलेली मेथड आहे त्याच्यामध्ये ते पॉइंट्स न गृहीत धरता फॉरबिनेस मेथड न कशी आपल्याला ती सोडवता येईल.
फॉरबिनेस मेथड इज स्पेशली अप्लाइड फॉर दोज डिफरन्शियल इक्वेशन दॅट हॅव सिंग्युलॅरिटी.
बरोबर.
बरोबर आहे का नाही? लिजेंडरी डिफरन्शियल इक्वेशनला सिंग्युलॅरिटी +1 -1 ला येते. अनेक रेफरन्स बुक मध्ये हे चुकीचं आहे. x इज इक्वल टू 0 ला तुम्ही पॉवर सिरीज सोल्युशन काढलेलं आहे.
आता हे मला वाटतं,
आता ऐका की, तसं जर तुम्ही गेला त्याचं स्पेशल ऍप्लिकेशन जर बेसल फंक्शनला घेतलं तर काय प्रॉब्लेम येत नाही सर, तर काही प्रॉब्लेम येत नाही. म्हणजे मला काय म्हणायचे, सिलेबस सेटिंग करताना ऍप्लिकेशन हे बेसलला घेतलं पाहिजे, लेजेंडरीला नाही घेतलं पाहिजे. लेजेंडरीला घेतलं तर मग ते सोल्युशन सिंग्युलॅरिटी x इज इक्वल टू +1 किंवा -1 घेतली पाहिजे.
म्हणजे सिलेबस मध्ये ती करेक्शन त्यावेळी सुचली होती, बरोबर?
आणखी दुसरी एक करेक्शन आहे सिलेबस मध्ये, की
पाहिजे.
आणखीन एक करेक्शन असते, फॉर्बिनेस मेथड अँड स्पेशल फंक्शन. बरोबर आहे, स्पेशल फंक्शन आहे त्या ह्याच्यामध्ये कुठं स्पेशल फंक्शन नाही त्या चॅप्टर मध्ये.
तो पॉइंट त्यावेळी डिस्कस केला होता बरं का हे सर.
हा,
इथं जे सिलेबस आहे ना बघा, सेरीज सोल्युशन मेथड ऑफ सॉल्विंग सेकंड ऑर्डर लिनियर डिफरन्शियल इक्वेशन फॉर्बिनस मेथड टू लिजेंडरी डिफरन्शियल इक्वेशन. आता इथे एक तर हा चेंज करूया,
बेसल डिफरन्शियल इक्वेशन लिहायचं,
बेसल
असं तिथे लिहिलं पाहिजे.
आणि स्पेशल फंक्शन हा शब्द काढला पाहिजे.
कुठला कुठला कुठला
स्पेशल फंक्शन टायटल मधला, चॅप्टरच्या टायटल मध्ये स्पेशल फंक्शन असं लिहिलेलं आहे आणि एकही स्पेशल फंक्शन नाहीये त्याच्यामध्ये, एकही स्पेशल फंक्शन नाही आणि त्याच्यामध्ये तर लिहिलंय स्पेशल फंक्शन. किंवा मग अजून एक ऍडिशन अशी करावीशी वाटते, म्हणजे सुचवायची वाटते, सेरीज सोल्युशन मेथड आणि फॉर्बिनेस मेथड या दोघी मधलं डिफरन्शिएशन झालं पाहिजे. कारण मॅथमॅटिक्स मध्ये मुलं शिकत असताना सेरीज सोल्युशन शिकतात आणि इकडे नुसती फॉर्बिनेस मेथड. बऱ्याचदा लिजेंडरी डिफरन्शियल इक्वेशन आहे त्याचं सोल्युशन साध्या सेरीज सोल्युशन मेथडने काढता येतं, फॉर्बिनेसने काढता येतं, दोन्ही नाही काढता येतं.
आणि ते आपण केलंय सोल्युशन ऑफ दी लिजेंडरी डिफरन्शियल इक्वेशन बाय फॉर्बिनेस मेथड. ते
होय की सर, पण कसं आहे, फॉर्बिनेस मेथड इज अप्लाइड ओनली फॉर द डिफरन्शियल इक्वेशन दॅट हॅव सिंग्युलॅरिटी आणि लिजेंडरी डिफरन्शियल इक्वेशनला सिंग्युलॅरिटी आहे ती फायनाईट पॉइंटला आहे, झिरोला नाहीये. आणि सगळी सोल्युशन सगळी रेफरन्स बुक जर तुम्ही शोधली, सगळी रेफरन्स बुक तुम्हाला ह्याचं फॉर्बिनेसचं सोल्युशन x=0 ऑर्डिनरी पॉइंटला दिलेलं दिसेल. कुठल्याही रेफरन्स बुक उघडा तुम्ही, कुठलंही रेफरन्स बुक.
फक्त इथं काय केलं पाहिजे,
प्रॉब्लेम सॉल्व्ह केला पाहिजे ना तो प्रॉब्लेम. मग आपण
बरोबर आहे, कन्फ्युज करणार हे आर्टिकल लक्षात आलं बरं का.
कारण ही अँबिग्युटी राहणार शिकवणाऱ्याच्या डोक्यामध्ये. तर काय केलं पाहिजे, ते लिजेंडरी डिफरन्शियल इक्वेशनला ऍप्लिकेशन न देता बॅसलला द्या, प्रॉब्लेम सॉल्व्ह होऊन जातोय.
चालतंय चालतंय, इथं बेसिलला घेऊ आणि स्पेशल फंक्शन काढून टाकू.
तर आपल्याला सिलेबस मध्ये काय बदल करावा लागणार आहे का?
करावं लागणार की सिलेबस मध्ये बदल थोडासा.
मग आता कसं आपला तर झालाय बीओएस मध्ये पास,
नाही परत
पास झालाय पण चुकीचा पास झालाय, करणाऱ्याने सरळ केला नाही.
नाही बरोबर आहे कदम सर, पण आता काय करायचं?
त्याला अमेंडमेंट करता येते सर,
आता काय नाही, किल्लेदार सरांनी सांगितलंय तुम्हाला सोल्युशन बरं का.
अमेंडमेंट करता येते.
किल्लेदार सरांनी सोल्युशन मगाशी सांगितलंय की.
आता कदम सर तुम्ही काय करा, एक जरासा आम्हाला या संदर्भातलं एक पत्र पाठवा व्यवस्थित असं डिटेल मध्ये.
पत्राच्या आधारे आपण पुढच्या
त्याप्रमाणे आपण काय करूया, पुढच्या वर्षापासून
पुढच्या ह्याच्यात अमेंडमेंट करायची, आता नाही करायचं.
आता होत नाही,
आता होत नाही, आता आहे तसंच घ्यायचं.
पुढच्या वर्षी ते होईल.
वगैरे केलेलं आहे तसं केल्यात चालतं ना,
करता येते, काय अडचण नाही. तर मला वाटतं आपण पुढे जाऊया काय बघा.
ठीक आहे, फक्त सूचना होती म्हणून सांगितली.
नाही तुम्ही कदम सर जरा काय करा, डिटेल मध्ये आम्हाला जरा ते लिहून पाठवा.
बरं पाठवतो,
त्याप्रमाणे आपण ते करून घेऊया.
हॅलो किल्लेदार सर,
आपण
झाले का चर्चा संपले का ह्या टॉपिक वरची?
झाले.
मला जरा 1-2 प्रश्न विचारायचे सरांना.
हा बोला सर.
मोहिते सर ऐकू येते?
हा येते बोला.
तर ऑर्डिनरी डिफरन्शियल इक्वेशन आणि पार्शियल डिफरन्शियल इक्वेशन हा जो टॉपिक आहे तुम्ही चांगल्या पद्धतीने सांगण्याचा प्रयत्न केला, पण आपण मूलतः मुलांना डिफरन्शियल इक्वेशनचे प्रकार सांगायला पाहिजेत. हे इक्वेशन डिफरन्शियल इक्वेशन कुठं वापरतो, रिअल लाईफ मध्ये कुठं त्याचा वापर होतो, म्हणजे फक्त भौतिकशास्त्रातच त्याचा वापर होतो असं नाही, तर हेही मुलांना सांगायला पाहिजे असं मला वाटतंय. एखाद्या डिफरन्शियल इक्वेशनचं सोल्युशन निघत नसेल, म्हणजे अनालिटिकल सोल्युशन निघत नसेल, तर त्याचं न्यूमेरिकल सोल्युशन काढता येण्याच्या मेथड्स अस्तित्वात आहेत, त्या आपल्या सिलेबस मध्ये नसतील कदाचित. सर्व शिक्षकांनी हे ध्यानात घ्यावं की ते सोडवण्यासाठी आपल्याला वेगवेगळ्या न्यूमेरिकल मेथड्स आहेत, रंगागुट्टा मेथड असेल किंवा आणि कुठली मेथड असेल, तर त्याच्याविषयी नुसतं इंट्रोडक्शन करायला पाहिजे. मुलांना एखादं सोल्युशन सोडवून दाखवावं, म्हणजे पुढे जाऊन थोडस जादाच गोष्टी, म्हणजे डिफरन्शियल इक्वेशन कशाबरोबर खातात हे माहित नसते पोरांना. आणि डिफरन्शियल इक्वेशन वर हीट, साऊंड, फ्लुइड, इलेक्ट्रिसिटी, इलेक्ट्रोस्टॅटिक मॅग्नेटिझम, म्हणजे मॅक्सवेल्स इक्वेशन इलेक्ट्रोडायनामिक्स मधली जी आहेत ती टोटली डिफरन्शियल इक्वेशन्स आहेत. मग ही जी डिफरन्शियल इक्वेशनचा या ठिकाणी उपयोग होऊ शकतो, यानं सुरुवात करावी असं मला वाटते.
थँक्यू सर.
येस, थँक्यू.
ऍक्च्युली झालंय कसं सर, आता FY BSc, SY BSc आणि TY BSc असे 3 सिलेबस आता आपण CBS मध्ये घेतले.
बरं.
आणि आता TYचा सिलेबस ज्यावेळी आपण घेतला त्यावेळी आपल्यावर कन्स्टेंट आले की बाबा तुम्ही हा मी दिलेला सिलेबस आहे, ह्यातला तुम्ही एवढा सिलेबस घेतलाच पाहिजे.
नाही, मी माझा सिलेबस बदला असं नाही म्हणत.
नाही, ते नाही मला म्हणायचं. आता ज्यावेळी आपण पुन्हा सिलेबस घेणार आहे त्यावेळी FY, SY आणि TY मध्ये पहिले जे तुम्ही म्हणताय ना हे सगळे, आता हा फक्त आपल्याला आर्टिकल काय सिलेबस मध्ये इंट्रोडक्शन टू डिफरन्शियल इक्वेशन, मग त्यामध्ये किती घ्यायचं हा इथं प्रश्न येतो. म्हणून जस्ट आपलं टाइप्स ऑफ द डिफरन्शियल इक्वेशन आणि सोल्युशन ऑफ द डिफरन्शियल इक्वेशन, ऑर्डर, डिग्री, होमोजिनिटी, लिनियरिटी आपण आता इथे घेतली.
एक्झॅक्टली. मोहिते सर तुम्ही म्हणताय तोच मला म्हणायचंय. मी जे मुद्दे मांडले ते सांगण्यासाठी जास्त वेळ जाणार नाही आपला, हार्डली 15 ते 20 मिनिट जातील.
अगदी म्हणजे टीचिंग करताना ह्या गोष्टी तिथं त्या टीचर
सगळ्या शिक्षकांच्या निदर्शनास आणण्यासाठी मी हे सांगतोय की बाबा हे डिफरन्शियल इक्वेशन आपण कुठं कुठं वापरतो, उदाहरणं द्यावीत. आणि डिफरन्शियल इक्वेशनचं सोल्युशन समजा नाही तुम्हाला अनालिटिकल सोल्युशन काढता आलं नाही तर न्यूमेरिकल सोल्युशनच्या मेथड्स अस्तित्वात आहेत. आता उदाहरणार्थ थर्ड ऑर्डर डिफरन्शियल इक्वेशन सोडवण्याची आपल्याला पद्धत माहिती पाहिजे. पोरांना आपण सेकंड इयर पर्यंत सांगतो, सेकंड ऑर्डर पर्यंत सांगतो.
सेकंड ऑर्डर.
तर ह्या काही गोष्टी फक्त जादाच्या मुलांना माहितीसाठी असाव्यात म्हणून सांगाव्या.
ओके.
थँक्यू सर.
थँक्यू मोहिते सर. थँक्यू मोहिते सर. थँक्यू राजपुरे सर.
Thank you, Mohite sir. Now I would like to request Dr. T.J. Shinde sir to guide all the teachers about cathode ray oscilloscope, operational amplifier and timer IC 555. Dr. T.J. Shinde sir, member of POS, Associate Professor, KRP College, Islamabad.
किती लिहायचं? कागद सातारून 2 वेळा आणले.
सर एक मिनिट. ओके, स्क्रीन दिसते का सर? हॅलो. स्क्रीन दिसते ना? ओके. I am extremely sorry for interruption in the presentation during the morning session. Good afternoon, everybody. Initially, I am thankful to Principal Dr. S.K. Salunke, RajarshiChhatrapati Shahu College, Kolhapur, Coordinator and Head Department of Physics, Dr. Killedar sir, as well as Head Department of Physics, as well as Chairman of BOS Rajpure sir, and organized committee members of this workshop to give me an opportunity as a resource person of this session. Here we have to discuss about new changed syllabus of BSc Part 3rd Physics, paper number 10, digital and analog circuits and instrumentation. Dr. Killedar sir has initially discussed about topics first digital electronics and topic second is transistor amplifier and sinusoidal oscillation of unit first. He was discussed briefly about unit first. Now we have to discuss about remaining unit number second of these papers. Syllabus of unit second is related to instrumentation, syllabus of unit second is related to instrumentation. It consists of 2 topics. First one is for cathode ray oscilloscope and second is on operational amplifier and timer. We know that CRO and op-amp topics were previously studied in old syllabus of BSc Part 2nd as well as BSc Part 3rd. Now the topic first is the cathode ray oscilloscope. It consists of following subpoints. First one is the introduction of CRO, block diagram of CRO, principle, construction of CRT, application of CRO, measurement of AC and DC voltage, period time, frequency and phase difference, and dosages figure. And second topic is on operational amplifier and timer. Now, operational amplifier topic consists of following points. First one is the differential amplifier and its types. Op-amp, block diagram of an op-amp, op-amp parameters, characteristics of an ideal and practical op-amp, that is IC 741. Applications of op-amps. First application is the inverting amplifier, second non-inverting amplifier, adder, subtractor, differentiator, and integrator. And finally, we have to study the timer IC, that is block diagram of IC 55, IC 55 pin configuration, and application of IC 55 as a stable and monostable multi-operator. Now, first unit or first topic is the cathode ray oscilloscope. In this topic, first point is the introduction of CRO. In this point, we have to give the short information about CRO and its function as well as its use. Now, second point is block diagram of CRO. Now, in this point, we have to draw the block diagram of CRO and explain the function of each block. That is function of cathode ray tube, vertical amplifier, horizontal amplifier, sweep generator, trigger circuit, high and low voltage power supply. For CRT, it is not essential to discuss about the construction and working, but here we have to give only information in short. Now, give the principle of CRT, that is its function means its simple use to convert electrical energy into visible energy, as well as meaning of principle. Now, next point is the construction and working of CRT. In this point, draw the diagram of CRT with showing sections like glass envelope, electron gun, deflecting system, fluorescent screen. For explanation of electron gun, we also draw the diagram of electron gun, as well as in case of deflecting system, we can also draw the related diagrams. Now, the diagram of electron gun, in this case, we can explain the function of electron gun in detail. After that, deflecting system, we can also explain the total how to deflect the electron beam which is emitted from the electron gun by using the deflecting systems, and finally discuss about the fluorescent screen. Now, next point, application of CRO. Now, first application is the measurement of AC voltage. Now, in this point, explain the procedure of measurement of AC voltage. It is not essential to draw the circuit diagram, but with circuit diagram and waveform, student can easily understand. And therefore, we can, given the diagram of measurement of AC voltage as well as the sinusoidal peak. With the help of this, we can easily explain or easily understood the students the application of CRO as a measurement of AC voltage. Now, measurement of DC voltage. In this case also, we have to explain the procedure of measurement of DC voltage with circuit diagram and display the position of horizontal line, which is shown in the figure. That is the displacement of the shifting of line from its original position. It means that we have to measure the DC voltage with the help of CRO, and therefore the students can understood easily by using these diagrams. Next, measurement of periodic time. Here we can also explain
Shinde sir,
the procedure.
Shinde sir, 1 minute.
Okay.
Tell the formula how to measure the AC voltage, that is the deflection multiplied by the volts per division.
Okay. Sir,
at least mention
this syllabus is already is in old syllabus. Therefore, in today's today is workshop on a syllabus. There is no any clarify all that things. But here the measurement of AC voltage as well as measurement of DC voltage study is already completed in last syllabus, as well as this practical. This syllabus is also related to practical. That is why it is not necessary to display the formulas, but there is essentiality to take the formulas.
Listen me. So forget about the old syllabus. You should at least you should mention here. You should use this formula to calculate the AC voltage. That is very essential. Okay.
Okay.
Go ahead.
Okay. Now measurement of periodic time. Here draw the diagram, circuit diagram used for the measurement of AC voltage with sine wave form, and explain how to measure periodic time. And its formula is periodic time means number of division on x-axis into time per division of scale on one side. Now measurement of frequency, that here we have to use again the procedure same as that of a periodic time, and additionally explain how to calculate frequency. That is, frequency is the reciprocal for periodic time. Next, the measurement of phase difference. Here we can use this figure. That is, here we have to apply AC supplies or ADO oscillator 1 and ADO oscillator 2 for the vertical plates as well as horizontal plate, so that we have to get the loops, different loops on a screen, and with the help of these we can measure phase difference, that is theta is equal to sine inverse A divided by B. Also we can display the diagram usages figures, that is draw the different usages figures with various ratios of frequencies and also different phase angles. Now operational amplifier. Now first point is the differential amplifier. Here in this point we give the information about the differential amplifier and then the types of differential amplifier. There are 4 types of differential amplifiers. First one is the double-ended input and double-ended output differential amplifier. Second is the double-ended input and single-ended output differential amplifier. Next one is the single-ended input and double-ended output amplifier. And last one is the single-ended input and single-ended output differential amplifier. In this point, we draw all the diagrams and explain about it, and also give the relationship between output voltage and input voltage. Like in case of double-ended input and double-ended output, we have to relate the relation VO is equal to A in bracket V1 minus V2. Here V1 is the inverting terminal and V2 is the non-inverting terminal. Here VO is the output voltage. Now next point, op-amp. Give the information of op-amp, that is meaning of op-amp and its purpose for original use. Draw op-amp symbol and pin configuration and give details about pin configuration. That is, the pin number 2 is the inverting input terminal, pin number 3 is the non-inverting terminal, output is at a 6 terminal, observed at 6 terminal, plus VCC supply is applied across 4 terminal, plus VCC supply is given to the terminal number 7 of op-amp with respect to ground, and this is the pin configuration. Okay. Now next, block diagram of an op-amp. Now in this point, draw the block diagram of op-amp, and it consists of 4 stages. First one is the differential amplifier, that is double-ended input and double-ended output differential amplifier. Second stage is the Moore gain differential amplifier having double-ended input and single-ended output. Third is the level shifter, that is emitter shifter, and last one is here. Draw the diagram, block diagram, and explain the function of each block in detail. Now next point is the op-amp parameters. Now state and shortly explain the op-amp parameters with diagram. First one is the input offset bias, second is the input offset current, third input offset voltage, next slew rate, open loop gain, closed loop gain, frequency response curve, input impedance, output impedance, and finally common mode rejection ratio. It is essential to define the definition of all these parameters. Next, the characteristics of ideal op-amp as well as state the characteristics of ideal op-amp as well as practical ideal op-amps. The characteristics of ideal op-amps, that is IC 741, is the infinite loop voltage gain or infinite voltage gain. Next, infinite input impedance, infinite common mode rejection ratio, infinite bandwidth, infinite slew rate, zero output impedance, zero output voltage, zero input bias, and zero input offset voltage. This is the characteristics of ideal op-amp, that is IC 741, and the characteristics of practical ideal op-amps are open loop gain is about 1 lakh, input impedance is about 2 mega ohm, common mode rejection ratio is about 90 decibel, output impedance is about 75 ohm, closed loop gain is about 1000, slew rate is about 0.5 volt per microsecond, input offset voltage is plus or minus twice millivolt, input offset current is about 200 nano ampere. It is essential to state these characteristics during teaching. Now, applications of an op-amp. First application, use of op-amp as an inverting amplifier. Now, in inverting amplifier, input signal, that is AC signal, is applied to the inverting terminal of an op-amp, and non-inverting terminal is grounded. Now here, in this point, it is essential to draw the diagram in detail and describe about this diagram for finding out the closed loop gain and express its gain in the form of minus RF upon RE. Now, second application is the non-inverting amplifier. In this case, again draw the diagram of non-inverting amplifier of op-amp used as a non-inverting amplifier. In this case, input signal is applied to non-inverting terminal. In this case also, we have to describe all about this diagram or non-inverting amplifier and obtain the closed loop gain, and it becomes 1 plus RF upon RE. Next, op-amp as an adder. In this point, we can also draw the diagram like this and describe about use of op-amp as an adder, and finally obtain the expression of voltage, that is output voltage Vo is equal to minus RF upon RE in bracket V1 plus V2 plus V3. Now next application, op-amp as an subtractor. Here we draw the diagram and explain about it, and finally obtain the expression of output voltage Vo is equal to RF divided by Rin in bracket V2 minus V1. Next, op-amp differentiator. Now in this point we also draw the diagram. In this case, capacitor is connected in input minus RC dV in divided by dt, that is derivative of input voltage. This shows that output voltage is directly proportional to derivative of input voltage. Derivative of input voltage. Now next application, op-amp as an integrator. In this point, draw the circuit diagram. That is how to use op-amp as an integrator. In this case, capacitor is connected in feedback path. Here we can explain the function of op-amp as an integrator and also obtain the expression of output voltage. That is, output voltage is equal to minus 1 upon RC into integral of input voltage. Now next, timer. Now first point is the block diagram of IC55. In this point, draw the block diagram of IC55 and explain the function of each block in. Also give the information about pin configuration of IC55 and explain the function of or give the configuration of each pin. That is, pin 1 represent ground, pin number 2 that is trigger input, pin number 3 is the output, pin number 4 is the reset, pin number 5 is the control input, pin number 6 is the 7 discharge transistor, 8 plus V6. Now applications of IC55 as a monostable multivibrator. Now in this point or in this article, we draw the IC55 timer in the form of monostable multivibrator, or draw the circuit diagram of IC55 as a monostable multivibrator and explain how to capacitor charges and discharges through resistance RA in detail with waveforms shown here, and also obtain the expression of periodic time, that is T is equal to 1.1 RA into C. Next point is the application of IC55 as a stable multivibrator. In this point, we also draw the circuit diagram of a stable multivibrator and explain its working in detail and obtain the expression for time period, that is T is equal to 0.693 in bracket RA plus twice RB into C, and hence also obtain the expression for frequency, that is F is equal to 1.44 divided by RA plus twice RB into C, and also give the information about the charging, discharging period of RA, RB as well as RB, and the square wave from which we can determine the periodic time. And the reference books are referred for these topics are, first one is the op-amp and linear digital circuits by Ramakant Goykwad, basic electronics, a text lab manual by Malvino, electronics fundamental and applications JD Ryder, electronic principle Albert Malvino, a textbook of electronics by Chattopadhyay, basic electronics by Srinivasankar, and lastly basic electronics by Bhargav and Gupta. Okay, thank you. काय शंका असतील तर विचारावेत. हॅलो, हॅलो,
निमट सर.
हॅलो.
हॅलो निमट
हॅलो.
सर आहेत ना. हॅलो निमट सर.
हॅलो. जर का शंका असतील तर कृपया विचारा. शंका किंवा काय या सिलेबस संदर्भात जरा स्कोप्स आणि लिमिटेशन संदर्भात काय जर आपलं काय म्हणणं असेल तर कृपया आपण या प्लॅटफॉर्मवर.
निमट सर, I want to add one thing there.
Yes, please, sir.
बोला सर, बोला सर.
So in measurement of periodic time, you should discuss both the methods.
Okay,
First
AC
method
and
is
DC.
a direct method. So in direct method, we can directly measure the periodic time using CRO time-based calibration.
Right.
And second method is indirect method. That is the method by using a Lysa's figure. So we apply two signals unknown to the one deflecting plate and known signal to the other deflecting plate, horizontal deflecting plates and vertical deflecting plates. So this method also we discussed in our lecture hours, direct method and indirect method of. Then again, as Shinde sir told that when you are considering the applications of operational amplifier, you should also derive the relation. You should derive the relation for the inverting amplifier, non-inverting amplifier, adder, subtractor, etc. And the concept of virtual ground. The concept of virtual grounds should be made clear to the students, particularly in op-amp, as it has got a very high input impedance. So that should be very clear. So all these points should be considered when you are teaching the topic operational amplifier. One more thing, there should be a comparison between normal amplifier and differential amplifier. When you are teaching differential amplifier, there must be a comparison should be made between a normal amplifier and the differential amplifier, so that the student will know that what are the advantages of differential amplifier. Why we should study IC like operational amplifier 741 in this chapter. So I particularly request all the teachers to make the emphasis that why should we are studying operational amplifier as a IC 741? Why should not other ICs considered? So you should discuss the properties of ideal operational amplifier, practical operational amplifier. That should be discussed. That is very important. Again, you should give emphasis on timer IC55, because a time signal waveform of required time interval in microsecond or millisecond can be very accurately generated by using IC timer 55. So this is the topic related with electronics. In first topic we have studied digital electronics. I have also mentioned reference of clock signal. So the timer 55 IC is basically very suitable for generating a clock signal of required frequency. And timer IC55 has a number of applications in control circuits. So that emphasis should be given when you are teaching the topic like timer 55. So that we can increase the interest of our student. Even though you can give small project to BSc students based on timer 55s, like we can switch on the radio, we can switch on the TV after a particular interval of time. Suppose I want to switch on the TV after half an hour interval, then I can use a monostable multivibrator. So by using a monostable, it is possible to make a particular circuit on for a particular interval of time. So such sort of examples should be one when you are teaching the topics like astable multivibrator, monostable multivibrator, or bistable multivibrator. So firstly, clearly give the idea about the difference between the monostable, bistable, and astable, and where these circuits are used. So this topic will become more and more interesting. Shinde sir has already explained nicely the use of CRO, then the use of operational amplifier, no doubt. But these are my opinions regarding this.
Okay,
Thank you.
सर. हॅलो शिंदे सर.
हा बोला सर.
हॅलो.
हा बोला सर.
याच्यामध्ये क्वालिटेटिव्ह एक्सप्लेनेशन ऑफ कॉमन मोड गेन आणि डिफरन्शियल मोड गेन ह्याच्याबद्दल आहे ना ते.
घेणं आवश्यक
आहे ना. ते तेवढं विचारायचं होतं मला.
नाही सर, घेणं आवश्यक आहे.
संदर्भ आला नाही.
त्याच्याशिवाय आपल्याला पुढे ऑफिशियल ऍम्प्लिफायरचा इन्व्हर्टिंग आणि नॉन इन्व्हर्टिंग ऍम्प्लिफायरचा कन्सेप्ट क्लिअर करता येत नाही.
येत नाही तो नाही पॉईंट आला म्हणून मी विचारला.
नाही काय केलं सर की कव्हर करत असताना जे आपल्या सिलेबसचे पॉईंट आहेत त्या पॉईंट बद्दल मी जास्त डीप मध्ये टीच न करता, आता हे सगळे टीचर्स आहेत त्यामुळे टीचिंग करण्याचा हा मुद्दा नाहीये. हा फक्त आपले जे पॉईंट आहेत सिलेबस मधले जे काही पॉईंट आहेत ते कसे घ्यावेत, त्यात काय असणं आवश्यक आहे एवढ्यासाठीच फक्त आपण बोललो. म्हणजे टीचिंग होऊ नये. खरं म्हणजे माझ्या पुढे सगळे शिक्षक आहेत, म्हणजे माझ्यासारखे शिक्षक आहेत, माझ्यापेक्षा जास्त वयाने शिक्षक आहेत. मग त्यांना मला असं वाटतं की बाबा टीच होऊ नये म्हणून मी त्या पॉईंटला धरून बोललो की हा पॉईंट असा घेणं आवश्यक आहे. पण तो पॉईंट मी डिस्कस नाही केला की आता मला ऑपरेन्शियल ऍम्प्लिफायर आणि इन्व्हर्टिंग ऍम्प्लिफायर मला घ्यायचं म्हटलं तर मी तो डेरिव्हेशन पण काढू शकतो. फक्त डिराइव्ह एक्सप्रेशन करायचं आहे असं फक्त आपल्याला म्हणायचं आहे. एक्सप्रेशन काढणं आवश्यक आहे. पण इथं मी तुम्हाला डिस्प्ले करणं इट नॉट इसेन्शियल असं मला वाटतं बरं का. माझं ओपिनियन आहे. सिलेबस डिस्कशन करतो आपण तो त्या सिलेबसच्या पॉईंटला धरून बोलतो की तो सिलेबस बद्दल कसा शिकवला जावा हे ठीक आहे, मान्य आहे. पण तो असा पूर्ण इथपर्यंत घेतला पाहिजे, असं केलं पाहिजे हे मला वाटतं की अपेक्षित नसावं.
ओके सर, ओके.
हा सरांनी जो प्रश्न विचारला तिथे ते डेरिव्हेशन त्याची घेण्याची काय आवश्यकता नाही
आहे. डेरिव्हेशन घेणं आवश्यक आहे सर.
एक मिनिट, मी आय एम डिस्कसिंग अबाउट द कॉमन मोड गेन.
ओके.
हा तिथं काय तुम्हाला ते डेरिव्हेशन करायची गरज नाही. डायरेक्ट इक्वेशन देऊन तुम्ही
कॉमन मोड रिजेक्शन रेशो बद्दल आपल्याला सांगणं आवश्यकच आहे.
डेफिनेशन सांगा. फार डीप तिथे करायची गरज नाही. डीप करायची काही गरज नाही.
शॉर्ट मध्ये घेऊ शकतो आपण.
शॉर्ट मध्ये इक्वेशन लिहा आणि एक्सप्लेन करा. फक्त मिनिंग सांगा त्याचा. कॉमन मोड काय आहे, CMRR. इव्हन तुम्ही ओपन लूप गेन म्हणजे काय ही कन्सेप्ट मुलांना सांगितली पाहिजे. क्लोज्ड लूप गेन म्हणजे काय हे मुलांना सांगितलं पाहिजे. कारण आपण ज्यावेळी फ्रिक्वेन्सी रिस्पॉन्स कर्व डिस्कस करतो त्यावेळी फ्रिक्वेन्सी रिस्पॉन्स कर्व मध्ये आपण दोन्ही गोष्टी डिस्कस करतो. म्हणजे ओपन लूप गेन कसा बदलतो, क्लोज्ड लूप गेन कसा बदलतो याबद्दल आपण तिथे डिस्कशन करतो. म्हणून तुम्ही तिथे सांगितलं पाहिजे की फीडबॅक ज्यावेळी इन्व्हर्टिंग ऍम्प्लिफायर आहे त्यावेळी आपण तिथे एक फीडबॅक रेजिस्टर कनेक्ट करतो, इनपुटला एक रेजिस्टन्स जोडतो. म्हणजे हे तुमचं क्लोज्ड लूप सर्किट तयार झालं. कारण ओपन लूप गेन ऍम्प्लिफायरचा वेगळा येतो, क्लोज्ड लूप गेन ऍम्प्लिफायरचा ऑपरेशनल ऍम्प्लिफायरच्या या ज्या व्हॅल्यू आहेत त्या वेगळ्या आहेत. त्यामुळं त्याबद्दल पण थोडंसं बोलावं शिकवत असताना. ओपन लूपचा मिनिंग काय, क्लोज्ड लूपचं मिनिंग काय वगैरे सांगावं.
Yes, anybody has a query, then please ask. Otherwise, we will conclude the session.
आतापर्यंत काय झालंय की सकाळपासून निमट सर बोलतायत, मी बोलतोय, शिंदे सर बोलतायत, राजपुरे सर बोलतायत.
नाही ते मध्ये ते त्यांना शेअर झालं नाही ना.
तर थोडंसं मला वाटतंय अजून सुद्धा आपल्यामधल्या टीचरनी जर काही त्यांची क्वेरी असतील तर बोलायला हरकत नाही, मोकळेपणानं बोला. कारण हे जे विद्यापीठानं आपल्याला वर्कशॉप घ्यायला सांगितलेलं आहे ते याचसाठी आहे की BOS मध्ये 4 माणसांनी बसून तो सिलेबस ठरवला. पण बरीच म्हणजे आमची ही फील्डवर काम करणारे असतात आणि त्यांचे फील्डवरचे अनुभव वेगळे असतात टीचिंग करत असताना. म्हणून या वर्कशॉपमधून तशा प्रकारचं आउटपुट निघावं. जर काही टीचरना अडचणी असतील, त्यांना वाटत असेल की हे असं नको असं पाहिजे, स्वातंत्र्य आहे. फक्त एवढीच गोष्ट गरजेची आहे, मी पुन्हा पुन्हा सांगतोय की तुम्हाला जे काही वाटतंय ते तुम्ही लेटरच्या द्वारे BOSला कम्युनिकेट केलं पाहिजे. नाहीतर मग काही जण माणसं म्हणत असतात की BOSच्या मनाला आलं ते ठरवतात आणि करतात. तसं अजिबात नाही. कारण मी BOS जॉईन केल्यापासून तरी आमचा अप्रोच तसा नाही आहे. कारण आपल्या सर्व शिक्षकांना घेऊन जाण्याची आमची मानसिकता आहे. आत्ताचं जे BOS आम्ही ठरवलं आहे त्याच्यामध्ये ठीक आहे, आम्ही 10 जण तिथं BOS नियमाप्रमाणे असू, पण आम्ही तुमचं प्रतिनिधित्व करतो सर्व शिक्षकांचं. त्यामुळे माझी शिक्षकांना सर्व विनंती आहे की तुम्हाला शिकवत असताना ज्या काही अडचणी आल्या असतील किंवा तुम्हाला वाटत असेल हा टॉपिक जरा असा घेतला असता तर आणखी उत्तम झाला असता, हे इथे इन्क्लूड केलं असतं तर फार छान झालं असतं, तर तुमच्या लेवलवर कॉलेजमध्ये टेबलला गप्पा मारू नका. कारण त्या गप्पा मारून त्याचं काही आउटपुट नाही. शेवटी याचा आउटपुट कधी येऊ शकेल जर तुम्ही रितसर आम्हाला BOSला जर पत्र लिहिलं की आणि व्यवस्थित लिहा पत्र. तुम्हाला जे काय म्हणायचं आहे ते त्या पत्रामध्ये व्यवस्थित लिहा. म्हणजे कसं असतं, BOS परत तुमच्या आलेल्या पत्रावर ऍक्शन घेतं हे लक्षात घ्या. ते पत्र बाजूला ठेवलं जात नाही, कारण BOS मध्ये परत आम्ही एक कमिटी नेमतो आणि त्या कमिटीला आलेली सर्व पत्र सुपूर्द करतो. ती कमिटी 4 माणसांची असते आणि त्या पत्रांच्यावर विचार केला जातो. त्यातले जे योग्य सूचना असतील त्या सूचनांचा विचार केला जातो आणि तशा प्रकारचा ठराव करून तो पुढच्या वर्षी सिलेबसमध्ये ज्या गोष्टी ऍड करायच्या असतील त्या केल्या जातात. जर तुम्हाला आठवत असेल तर बघा, FY BSc मध्ये रेडेकर सरांनी एक आम्हाला पत्र पाठवलेलं होतं आणि त्या कोर्समध्ये आम्ही तसा बदल केलेला आहे बघा. म्हणजे ग्रीन्स थेरम असेल, स्टोक्स थेरम असेल,
सिलेबस मध्ये बदल केला
तुम्हाला डेरिव्हेशन घ्यायला सांगण्यात आलं. हे कधी घेतलं तर रेडेकर सरांनी आम्हाला एक व्यवस्थित विस्तृत असं पत्र लिहिलेलं होतं आणि त्यांनी त्याचं एक्सप्लेनेशन पण दिलेलं होतं की मला असं का वाटतं हे इथं घालावं. आणि हे मग आम्ही कमिटी नेमल्यानंतर आमच्या लक्षात आलं की हे योग्य आहे. त्यांनी ज्या काही सूचना मांडल्या त्या बरोबर आहेत आणि त्याप्रमाणे लागलीच आम्ही परत एक ठराव करून सिलेबसमध्ये बदल केला आणि तो तुम्हाला एक सेपरेट पत्र आले बघा. काही शिक्षकांनी बघितले का नाही बघा, नाहीतर जुनाच सिलेबस शिकवत बसला. कारण जो काही बदल झाला त्या संदर्भातलं एक सेपरेट पत्र पाठवलेलं आहे विद्यापीठानं की या टॉपिकमध्ये असा असा बदल झालेला आहे आणि त्याप्रमाणे त्याची नोंद घ्यावी. त्याप्रमाणे तुम्ही लोकांनी सुद्धा जर आम्हाला काही फीडबॅक दिला तर आपल्याला बदल करता येईल. कारण शेवटी आपल्या सर्वांचा उद्देश काय आहे, आपल्या विद्यार्थ्यांना आपला विषय चांगल्या पद्धतीनं मिळावा आणि ही जबाबदारी आपणा सर्वांची आहे. सर्व शिक्षक असतील, सर्व BOS मेंबर असतील, पण BOS मेंबर हे तुमचे प्रतिनिधित्व करतात लक्षात घ्या. आणि त्यांना जो काही इनपुट डेटा द्यायला पाहिजे तो सर्व शिक्षकांनी जर व्यवस्थित इनपुट डेटा पुरवला तर आम्हाला BOS मध्ये काम करायला आणखी ते सोयीचं पडेल. म्हणून परत एकदा मी BOS मेंबर म्हणून तुम्हा सर्वांना विनंती करतो की तुमच्या सूचना ज्या काय असतील, तुम्हाला जे काय वाटत असेल ते तुम्ही पत्राद्वारे BOS ला कळवा. त्याच्यावर नक्कीच विचार केला जाईल. ओके, अजून कोणाला काय म्हणायचं असेल तर बघा.
का शंका असेल, काय रिमार्क करायचं तर राजपुरे सर असतील तर राजपुरे सर.
राजपुरे सर बोला.
नाही बरोबर आहे सरांचं म्हणणं, बरोबर आहे की आपण स्कोप हा ठरवायला पाहिजे आणि किती घ्यायचं फिजिक्सला स्कोप तसा नसतो. म्हणून हे वर्कशॉप मध्येच आपण ठरवायला पाहिजे की बाबा इथपर्यंत जायला पाहिजे. नाहीतर काय होतं, एखादा शिक्षक अमुक एखाद्या पॉइंट पर्यंत जातो आणि दुसरा आणखीन त्याला पुढे घेऊन जातो. मग जरा सुसूत्रता असावी. मग या स्पीकरनेच सांगावं की इथपर्यंत शिकवायला अपेक्षित आहे, या गोष्टी कव्हर करणं अपेक्षित आहे. त्यामुळे TJ शिंदे म्हणतायत ते पण बरोबर आहे की आणखीन जास्त त्याची ही वाढवण्यापेक्षा आपण सीमित कुठंतरी करायला पाहिजे. आणि किल्लेदार सर म्हणतात तसं पण बरोबर आहे की त्या पुढे जाऊन थोडस ते जे CMMR चं इक्वेशन आहे ते इंट्रोड्यूस करायला पाहिजे, सांगायला पाहिजे. त्यात काही जास्त वेळ घालवण्याचं कारण नाही. तुम्ही इक्वेशन सांगणं म्हणजे ते डिराईव्ह करणं नव्हे. बरोबर ना किल्लेदार?
बरोबर बरोबर. निदान त्याला ती संकल्पना तरी माहित असली पाहिजे. कॉमन मोड रिजेक्शन रेशो
बरोबर
जे डिफरन्शियल ऍम्प्लिफायरचं वैशिष्ट्य आहे. कारण नॉर्मल ऍम्प्लिफायर मध्ये यू कॅनॉट रिमूव्ह द नॉईज.
बरोबर.
नॉईज हा फार महत्वाचा विषय असतो ऍम्प्लिफायर मध्ये आणि तो तुम्ही ट्रान्झिस्टर ऍम्प्लिफायर मध्ये नाही काढत. जर तुम्ही इथं डिफरन्शियल ऍम्प्लिफायर वापरला तर तुमचा हा नॉईज जो आहे, कॉमन मोड सिग्नल आहे, तो तुम्हाला कमी करता येईल. ती संकल्पना थोडीशी सांगणं पण गरजेचं आहे CMRR. कारण इन्स्ट्रुमेंटेशन ऍम्प्लिफायर मध्ये ऑपरेशनल ऍम्प्लिफायरचा जास्तीत जास्त उपयोग केला जातो.
बरोबर.
अजून इथं ह्याच्यावर भर दिला पाहिजे की ऑपरेशनल ऍम्प्लिफायरचा गेन खूप हाय असतो आणि म्हणून आपण बघतो की जे वीक सिग्नल असतात, जे स्टार्स, उदाहरणार्थ एखाद्या स्टारचा अभ्यास चालला असेल, समजा स्टार कडून येणारे सिग्नल कॅप्चर करत असो आपण, JMRT सारखी जी लॅब आहे नारायणगावला, तर हा पण विषय मी मुद्दाम इथे मांडतो. JMRT ला एक मोठी अँटेना आहे, तर तिथं सुद्धा ट्रिप आपल्या विद्यार्थ्यांना घेऊन काढण्यास काही हरकत नाही. एक 40 किलोमीटरच्या एरियामध्ये 30-40 मोठ्या खूप डिश अँटेना बसवलेल्या आहेत आणि अशा ठिकाणी स्टारचा अभ्यास केला जातो, आकाशगंगेतल्या ताऱ्यांचा अभ्यास केला जातो आणि तिथून येणारे जे सिग्नल असतात ते खूप वीक असतात आणि ते मग ॲम्प्लिफाय करण्याची आवश्यकता असते. अशा ठिकाणी तुमचा ऑपरेशनल ॲम्प्लिफायर नक्कीच तुमच्या मदतीला येतो. तर हे पण थोडंसं असू दे. बघा, कधी सवड मिळाली, मुलांना घेऊन जायला मिळालं तर JMRT खोडत या ठिकाणी तुम्ही नक्कीच एक एज्युकेशनल ट्रिप काढण्यासारखा स्पॉट आहे, पाहण्यासारखी गोष्ट आहे, तर ते पण करायला हरकत नाही.
चालेल चालेल, बरोबर आहे सर. माझ्या आवडीचा विषय हा. मी पूर्ण लेक्चर ऐकलं, टीचे शिंदे सरांचं ऐकलं, किल्लेदार सरांचं पण ऐकलं, कारण माझा इलेक्ट्रॉनिक्स विषय असल्यामुळं मला पण दिवसातून ऐकायला मिळालं. आणि मॅथमॅटिकल फिजिक्स जे आहे तो मोहिते सरांनी सुद्धा चांगल्या पद्धतीने सांगितलं. आमच्या गुरुजींनी जी स्पेशल फंक्शन सांगितली, बीटा फंक्शन, गॅमा फंक्शन, ती सुद्धा म्हणजे सर्वच वक्त्यांनी अतिशय ऍक्टिव्हली पार्टिसिपेशन घेतलं. आणि हा वर्कशॉप ज्या पद्धतीने अपेक्षित होता त्या पद्धतीने डेलिब्रेशन झाले असं मला वाटतं किल्लेदार सर.
हो, आणि विशेष करून LD कदम सरांचे आभार मानले पाहिजे.
हो हो, LD कदम सरांनी सुद्धा
प्राचार्य असून सुद्धा ते आपल्यात सामील झाले.
दिवसभर आहेत.
आपण सगळे सामील होतोय, आपण सगळे सामील व्हायचे पुढच्या
आवड असणारा माणूस.
राजपुरे सर,
बोला सर.
काय नाही, तो 2 चॅप्टर आहेत, म्हणजे फोरवेनियस मेथड. त्या फोरवेनियस मेथड मध्ये डिफरन्शियल इक्वेशन आपण कन्सिडर करतोय, ऑर्डिनरी पॉईंट काढतोय आणि सिंग्युलर पॉईंट काढतोय.
कळालाय सर, तर आपण करू ते अमेंडमेंट.
नाही, त्याच्यामध्ये मुद्दा असा होता बरं का सिलेबस सेटिंग मध्ये, की ऑर्डिनरी पॉइंट साठी पॉवर सिरीज सोल्युशन असतं,
बरोबर,
ते पण घेतलं पाहिजे. आणि जे सिंग्युलर पॉइंटचे डिफरन्शियल इक्वेशन असतं त्याचं सिरीज सोल्युशन असतं, त्याला आपण फोरवेनियस मेथड म्हणतोय.
हो हो, बरोबर आहे.
ते दोन्ही दाखवलं पाहिजे हो, म्हणजे ऑर्डिनरी पॉइंट का सिरीज सोल्युशन.
असं तुमच्यासारख्या सिनियर माणसांनी सांगायला पाहिजे, ह्या चर्चेत भाग घ्यायला पाहिजे. कदम सर, अडचण अशी आहे की आपले जवळजवळ 120 किती आहेत सर शिक्षक? मग त्यापैकी फक्त आपल्याला 44 दिसत आहेत. मग सगळ्यांनी भाग घेतला पाहिजे ना. आणि कसं आहे
सर, त्याच्यामध्ये आणखी पुढचा महत्वाचा मुद्दा आहे,
सांगा.
की त्या चॅप्टरचं नाव आहे अँड स्पेशल फंक्शन.
आणि स्पेशल फंक्शन एक पण नाही.
स्पेशल फंक्शन एक पण नाही, म्हणजे
बरोबर आहे, बरोबर.
लेजेंडरी पॉलिनॉमियल, हार्माइट पॉलिनॉमियल, बेसल पॉलिनॉमियल ते पण नाही. मग नसेल तर ते शब्द
घालूया सर, घालूया अमेंडमेंट मध्ये, घालूया ते. चालते.
राजपुरे सर, कदम सरांच्या ती जबाबदारी टाकलेली आहे.
चालेल चालेल चालेल.
त्यांनी त्या कोर्सचं काय असेल ते सगळं बघून घ्यावं व्यवस्थित.
त्यांनी पत्र लिहावं BOS ला.
आम्हाला एक पत्र लिहावं, पुढच्या वर्षी ते आलेलं दिसेल त्याच्यात.
मी काय म्हणतोय कुल्यादार सर, आता जे चेअरमन आहेत ना, आता त्यांना चेअरमनशिप दिली.
आता हे बघा, तुम्हाला चेअरमन करायचं म्हटलं तर तुम्ही प्राचार्य, त्यामुळे आम्हाला तुम्हाला काय करता येईल नाही.
तसं माझ्याकडे कामाचा व्याप असणार आहे, ते चेअरमन लोकांच्याकडे जबाबदारी टाका.
नाही राजपुरे, नाही सर, कदम सर काय माहितीये का, राजपुरे सर जसे आता म्हणाले की अनुभवी माणूस असल्याशिवाय ते सुचत नाही. लक्षात घ्या, हा पण भाग महत्वाचा आहे त्याच्यात.
बरोबर आहे, बरोबर आहे, तुम्ही म्हणताय.
चालतंय सर, झालं का? मी होऊ का?
मीटिंग करा करा करा, आता आभार व्यक्त करतील.
चालेल चालेल, धन्यवाद सर.
अर्चना मॅडम.
Thank you, Shinde sir, and all the teachers for your valuable guidance. Let's have a special recognition to all the personalities who have joined with us in this entire day. I would like to call Dr. A.R. Patil ma'am, coordinator of this workshop, to propose vote of thanks and to give finishing touch to this nicely conducted workshop.
Thank you, ma'am. Good afternoon, everyone. It's my privilege to offer thanks on this occasion. I would like to acknowledge our esteemed chief guest, Professor K.Y. Rajpure sir, Head Department of Physics, Shivaji University, BOS Chairman in Physics of Shivaji University, Kolhapur, who took the time out of his busy schedule and showered us with his pulse of wisdom and knowledge. We are truly humbled by your presence. Thank you, sir. I am grateful to Dr. R.S. Dubal sir, Vice Principal of our college, presiding this workshop and guiding us. I am grateful to Principal Dr. S.T. Samke sir for his wholehearted support and valuable guidance. I am very much thankful to resource persons of today's workshop, Dr. V.B. Killedar sir, Dr. T.J. Shinde sir, Dr. J.B. Thorat sir, Dr. U.K. Mohite sir, who enlightened us with their deep knowledge about the subject. I am thankful to chairpersons of today's workshop, Dr. R.K. Nimat sir and Dr. M.M. Tonpe sir. I am also grateful to Principal L.D. Kadam sir, SS College Ramanand Nagar, for his presence of this workshop. I am thankful to Dr. V.V. Kiledas sir, HOD Physics, for his valuable guidance. I am also thankful to entire HODs from my college for their help. Well, all ladies and gentlemen, such an event cannot happen overnight. Wheels starts rolling around a week ago. It requires planning and a bird eye for details. We have been fortunate enough to be supported by a team of very motivated and dedicated colleagues from our college who know their jobs and result oriented. I am very much thankful to organizing committee members of this workshop. I am also thankful to Ms. Mavika Madam for very nice anchoring of this workshop. I am grateful to Mr. Aniket Jadhav for providing technical help to organize this workshop with great success. I am also grateful to all teaching and non-teaching staff of our college. I want to thank to Shivaji University for sponsoring this workshop. And the essence of fruit is always tasted in the last, and we believe that the last will be the best. I would like to thank all our participants for their overwhelming response. Thank you one and all. Thank you very much. With the permissions of President, I declare that the workshop is over. The feedback link is shared on Telegram channel and it is shared on the Zoom meeting also. Please fill this feedback form. We'll send you printable certificate and e-certificate also. Thanks for joining us. Thank you very much. Have a nice day.
Thank you. आता बंद करायला पाहिजे झालंय या इंजिन सकाळी जे केलं असं म्हणजे मस्त
आमचं पण सर तरी बरंच नवीन घातलेलं ते आम्हाला कळलं ना केवढं
तुम्हाला कोणी बोलू नका म्हटलंय आणि घेतलं एक की म्हणाव बाबा या वायुवेगानं